Hello everyone, welcome to my stream today. I'm going to be flying this one solo. I'm going to be talking about what went into building Solid 1.5. So this isn't going to be just a stream about the features. I'm going to actually talk about the implementation, the design, the decisions that went behind it. So this is probably going to go pretty in depth. Hopefully you're all in for that. That's what we do around here, right? So gonna give everyone a second to join in on the stream. Just gonna pump it here on social channels. Just give me a second while we get started. Let's see here, yeah. I've been trying to decide whether I should be pushing Twitch more or should be pushing YouTube. It's kind of a interesting balance. I started everything on YouTube and I quite like that, but to be fair, Twitch has a certain amount of interactivity that's pretty cool. So yeah, people are starting to trickle in. All right, perfect. How's everyone doing today? There you go. See, we got some different opinions here. Some Twitch bias going on. and apparently YouTube has less where is it? Here. Yeah, YouTube has some less latency in South Africa apparently. So, maybe there's no clear winner here. All right. No, I always enjoy these streams like this one because I get to kind of talk about what I've been working on and in more detail. Half the time we're looking at more than half the time probably what other people are working on. But these ones always get to be a bit of a showcase and kind of talk through a lot of the decision points that matter to me, so to speak. Yeah, thank you. Yeah, no, 1.5 has been going on for a little bit now, honestly. So yeah, it's, we'll talk about that in a minute. I'm just welcoming everybody on here as we get started. Just given a couple more minutes. I think I've shared the link in all the proper places now. So let's give just another minute or so. I'm gonna do this week in JavaScript later, like I've been doing recently with the guest streams. I think it just works better that way. You gotta wait for my hot takes, so to speak. Not that I'm sure they're that hot, but you guys definitely got me last week with the bun announcement. I wasn't prepared for that, or not bun announcement. Sorry, the Dino announcement. I wasn't prepared for that. It was pretty. I don't know what the term is. Just off the cuff. I was not ready. This week I did pay a little bit more attention in there because, well, I mean, how could you not? The conversations this week have been all around that, but we'll get to that later on in the stream, right? Because we're here mostly to talk about what's been new with Solid and Solid 1.5. Yeah, nice people coming in from all over the world. It looks like that's awesome. All right. Looks like we have more YouTube representation than Twitch right now, though. So people on Twitch got some work to do. I don't know. It's probably work I have to do. I think there's a big gap between having. I think I have 3,000 subscribers on YouTube and 200 on Twitch. So we got a bit of a gap to cover. All right. How's people still coming in? Yeah. What do we got? Pakistan? Well, I guess the new streaming time has helped some people. It's probably pretty late where you are, but I used to stream at 8 p.m. Pacific, which meant it would be 3 a.m. or 4 a.m. for you. So glad you can all make it. It's hard. You can never get a perfect time for everyone. Someone was like, "Oh, can you stream something more EU friendly?" And it's possible, obviously. We went a little bit earlier, but perfect time for you. Great to see you, Alex. All right. Lots of hot topics. Yeah. And honestly, for the stream, I want you guys to kind of keep me honest, because I'm gonna be talking about implementation. I'm gonna be talking the details, and sometimes I get caught up on those, and it's gonna, if you have a question, you don't understand what I'm talking about, please ask in chat. Please, like no bad questions here. I want to make sure what I'm saying makes sense, because sometimes the stuff is pretty complicated, and I've spent so long in this like narrow focus that I'm like, I don't realize like how off the deep end I've gone. All right. Yeah. Okay. I guess it's been 5 minutes of me just rambling, waiting for things to get started. So I probably should get started, right? Like that's why we're here. Yeah. Maybe I should create a banner so I can remember where I started. Not that. Here we go. Let's see. So is everyone ready? Better than 5 in the morning. Yeah. Oh, yeah. All right. Well, it looks like we got some people here. Okay. So let's get started and talk about Solid 1.5, which is a release that's been in the works, I would say, since July-ish. Sometimes when I'm working on one minor release, like there's so many bug fixes that I'm just chasing the previous one for quite a while. Like between 1.3 and 1.4, there was a lot of bug fixes. We did a lot of SSR work in 1.3, like streaming, and did like basically completely updated our capabilities on what we could do with SSR. And this is really important for working on things like SolidStart. And I was working and ironing out bugs for weeks and weeks and weeks. Thank you to everyone who jumped in on those newer SSR technologies right off the bat and helped test it. It was incredibly valuable. But 1.5 was kind of a funny one, and let me explain why. Let me get my screen in here. Not like that, like this. 1.5 almost started immediately after the 1.4 release. Like sometimes you do everything and you plan everything out, and then you miss something small that's essential. And you go like, how did you miss that? Well, in our case, in Solid's case, there's certain APIs that we have that I never use, never recommend, and like just like I basically say like avoid unless you need to know what you're doing. And that seems like a weird choice. Like, why would you have APIs in Solid that you should never ever use? And the reason is it's not never ever. It's just sometimes there's edge cases. When you live in a reactive declarative world, there's boundaries to other code, other systems, and imperative procedures, things that already exist that you don't have control over. And essentially, in those situations, you do need other tools. You need to bridge that gap. And it's important to me, and it's always been important to me with Solid to bridge that gap, because that's how you can slide in and make the same kind of comparisons and stuff. Like if we didn't have like in Solid, you almost never need the data diff, but if we didn't have the ability to, I couldn't show how fast our approach is compared to VDOM libraries in heavy data diff situations. We wouldn't be able to, like, someone would have to build that. And for those like cases, that you need it, it needs to be there. But not every tool is for every job. And what happened in 1.4, I know this is a long wind up, is I added two features at the same time. Top level arrays in stores, which is the chef's kiss or whatever. Like I wish I'd thought of how to do this earlier. This was the thing that suddenly made stores and signals top level feel really nice, because you were kind of tempted previously to kind of put them all into like a single store and make these big singular store objects. Once we got top level arrays, you could just be like, this is a store, this is a signal, I understand, everything works nicely, you get rid of unnecessary nesting. It's a really big feature. But at the exact same time, we added it's funny, it's like a liner note here somewhere. Like it's not even like something that like made the headlines, but I fixed a very, very long time bug in Solid, which I don't even like. Did I even mention it in the release notes? Probably it was just like a simple bug fix, but it's probably buried in here somewhere. Yeah, wow, it's not even. I'm probably just not seeing it right now. Anyway, the problem was that Solid had this batching mechanism, this ability to kind of like put some changes together and apply them at the same time. Because if you're going to update a bunch of stuff, you don't want to like always just immediately update. And the problem was that stores never listened to it. They just ignored this mechanism. And since it came up so rarely, no one really noticed. And that, seemed like a good thing to fix. Like when we were thinking about, they also didn't obey concurrent rendering properly. You could get leaking and bleeding. So I was like, this is something really high priority from a mechanical standpoint, kind of in the background, not even maybe release worthy, that I want to fix. And I did that as part of 1.4, and we talked about it on the Building 1.4 stream. And what ended up happening was we were pretty happy with myself. I did the release, and like within the first day, someone's like, create mutable's broken. And I was like, wow, yeah, you're right. This actually just doesn't work. And that's pretty huge, right? You do this release, you work on it for, months, and you kind of figure out where the right balance of pieces and features are and where you want to be. And then you break something that, again, I never use and never recommend. But there are use cases, and some people like this primitive, and it's just completely busted because I fixed a bug. So right off the bat, I was like, okay, I didn't rush to it and try and patch it or something. This was too fundamental, and I didn't want to lose, like, I didn't want to just like trying to hack in some fix here, because like then it wouldn't make sense. I realized I had to rethink things a bit. And this kind of came at a perfect time where we started rethinking the future of Solid anyways. If you all aren't aware, started a working group here. It's pretty empty right now in terms of discussions. I think there's only like but I started kind of pitching ideas towards the future of reactivity in Solid 2.0, and there's actually a decent amount of discussion here, and people had ideas and proposals and stuff. Like you see, I'm still scrolling. Like this has been a really good process for us, and I hope to engage this more in the future. But what I want with all these kind of conversations happening simultaneously, 1.5 started a different place. It wasn't trying to necessarily chase the bugs, even though there was a big bug here, but it like actually go, well, we can't release this until we actually know what our future looks like. And that was a big part of it. Sorry, I just caught up on a comment on stream. I just want to throw this one in. I'm disappointed the name for 1.5 isn't the good batch, referring to the Star Wars The Bad Batch. The funniest thing is, I had suggested the Bad Batch, but then people were like, oh, people might not get that reference and think that it's like a bad release. It just didn't occur to anyone to say the good batch is like a reverse play on it. But yeah, I wanted to point this out because this was definitely in the short list. Anyway, so on that note, that's where I kind of want to start talking about Solid 1.5 today, because every piece of this basically started with us asking about what the future should look like. Solid loses interoperability with RxJS. I hope not. There was actually some feature improvements that were made as part of 1.6 to even improve observability. There's some small bug fixes and tweaks. So I believe there isn't an issue, unless you're aware of one that I'm not aware of. There was actually work done on the RxJS integration stuff as part of 1.5, but it was pretty minor, so I didn't end up talking about it in these release notes. But yeah. And so what I've done here is kind of set the stage, right? So we had a whole bunch of issues that kind of opened up all around the same time too. And before I talk about what we did in 1.5, I want to perhaps highlight what we didn't do. Okay, sorry, I should have made a banner for that. Because what we didn't do in 1.5 is actually more than you'd think. And I think it's important here to kind of give a basis so you can kind of understand a bit on this decision process. There's a couple issues here, and I'm just going to pull them up right now so you can kind of see what I'm talking about. But they were just like, let me see if I can find it. This is a good one, Boolean attributes. Another one. Yeah, okay, cool. I'm just gonna show you all a couple kind of funny issues you get when you're building a framework and you're just like, what, like a little bit of like, what's going on? Because the answers aren't always obvious, right? For example, this one was a funny one. Someone pointed out that error boundaries do not catch falsy values, and I went down a crazy rabbit hole here because people were like, no, if I throw undefined, I want it to like properly work with errors. And the same thing with create resource, error boundaries. People are throwing undefined and going like, why is this not like working properly? And you can understand why, because if you hold the error in a variable and the value is undefined, that's the same as if there is no error. So I went down this whole rabbit hole of trying to change everything so we could have undefined errors, and I realized that was like, this is one of those things. You can look at the discussion here. I started making like special symbols to define like there is no error, but then once you started moving things across boundaries, every single place I took an error as an argument now needed to go like past the second argument that's like, is there an error? And just kept on branching out and out and out, kind of coloring the whole code base. And I was like, people got to be messing with me. At a certain point, I got so frustrated with this issue that I was just like, why are you throwing undefined errors? So we actually changed the behavior here in a different way. We actually ended up saying like, if you throw like undefined errors, we're just going to make an error object that's like unknown error and handle it that way. I know that's kind of like taking a pretty big assumption there, but this had kind of gone completely out of hand because it was funny because I went through the code and I thought I hit all those points, but then when I re-implemented it with this like undefined error, I found a whole bunch of bugs because of stuff like invisibly failing because of this whole undefined thing. And now that partially could be my fault because of my lack of TypeScript skills or whatever, but trying to account for things that aren't there but are there is the weirdest experience. And I wasted like a week on this and it was the biggest waste of time ever, but I learned something important here because like, yeah, I mean, there's a lot of thought and talking in here, but this was just like the perfect example of how you can kind of get pulled down a rabbit hole for something that's like there's always edge cases, and you have to, I think the almost most important part is being able to explain them rather than actually even more so than like the fact that they exist, because sometimes it's not worth fixing them. And this was one of them. We had another really interesting one, and I'll kind of leave this open to you all to decide which way you think was the best way to handle it. But Boolean attributes, this is something that in the end we decided to not make a change, but it was noted that in Solid, if you had a Boolean attribute on an element, it would put in quotes here, essentially, like it does in HTML. But if you put a Boolean attribute on a component, it would pass true through. And this was kind of inconsistent. But the challenge here is you can spread things, right? You can spread values coming in from a component, and if the component, you lose the information of whether it's Boolean or not once you just have an object of props that is like foo true. So you have two options. Foo can either be true or foo can be empty string. when you have a Boolean property. And our position here is kind of inconsistent, because on a regular element, it's a string, but on a component, it's true. And in a sense, on a component, it has to be true, because, as I said, you can't differentiate. So there was, well, unless the proposal is to make it always an empty string, which is where we were kind of debating it. And this seems very logical from the HTML side of things, right? Like, because this is what you'd expect from HTML. But the funny thing is, I looked at JavaScript frameworks, and not a single one had taken this decision point. I already knew this like way back, but most people want true, funnily enough, to be true, which is kind of interesting, right? Because the problem is, if you look at the difference between the rows, there's like a difference here. And to be clear, this is only for non-Boolean attributes. And I know I'm getting kind of technical, but the way that React, most frameworks handle this is they keep track of which attributes are actually Boolean attributes versus not. And actually, you know what? I'm going to show you something really quickly here so you guys can understand what I'm saying. There are actually different, attributes that actually work differently. Like draggable only works if let me see, can I put draggable on the button? Yeah, there it is. Only works if you put true. If draggable is just there like this, it doesn't actually work. So there's like Boolean attributes and pseudo Boolean attributes. And this is kind of like, why is a DOM so freaking weird, right? And essentially, none of the frameworks actually have chosen to align with HTML. There's basically only two approaches that frameworks have chosen here. One is the way that Solid does, where it treats the element Boolean special, and actually Svelte has the exact same behavior. And the other one is you treat this one as true. So if you do this, it's the same as this, which is what Preact, React, and Inferno does. And arguably, in a sense, that one's more consistent, but it breaks expectation on standard DOM. So as I said, this is a very technical scenario. And you notice on the React version, draggable would be sufficient. Like this would work in React because it would make it draggable true. But in Solid, you actually have to make it true to actually do this, whether it's like this or the string. And this is like one of those interesting things. And actually the same is true as Svelte as well. It's just like the DOM, how much of the DOM do you hide from people, and how much do you change expectation here? Because on one side, you kind of wish that this would just work for draggable, but if this just works for draggable, then Boolean properties and stuff like, I think people were talking about, people were talking, not that one, people were talking about things like data properties don't work properly, like data HK and like a bunch of DOM stuff. Like this is another one of those places where the compromise is not great, right? Luckily, there's far less of these Boolean thing. Like basically, we know which properties are the defined DOM Boolean properties and how to handle them, and then we handle the rest in a way that reflects how they would be handled in HTML. So I think this is one of those interesting cases where some people are very strongly on one side, some people are very strongly on the other side, and it's weird, but we landed in the middle still, which meant it was no change and we continued on. But I just want, these are the kind of conversations that you start having when you get into this zone, right? Someone has a question. What about an own language like Solid or script body, text style, and language? People have done that. If you are interested in this, there are projects where people have done stuff similar to it. my opinion on this is like, if someone wants to put in the effort to do this, go for it. But it's a ton of work, like, because you suddenly don't get the free syntax highlighting and the prettier and linting and TypeScript, and like, you basically have to build the whole ecosystem from scratch. But yeah, I mean, if that's where you want to spend your time, then that it's maybe something worth doing. Anyway, so there was one other issue, but I'm not going to get too far into it, but it was about stores and wanting to remove the symbols. And I went through a bunch of benchmarking and realized that, there's performance implications. So again, we left it as no change. But really, with this release, the reason I wanted to highlight this before we got into the guts of it is I just wanted to talk about and show how much like debate and deliberation went over these very seemingly minor details, because these conversations are happening again, right? And yeah, I think that's enough for this kind of preamble here. Let's talk more about what we actually did with Solid, and a couple of them is the ones that I was pretty happy with. Before we again get into the more technical stuff, is I feel like this release again kind of improved, how should I put it? Quality of life improvements. That's how I'm going to call it. I was actually really stoked that a lot of other people came in and kind of helped contribute. One of them was Milo from the core team. Solid is now, if you notice, a PNPM workspace, turbo repo. It's easier than ever to get started, to download the project, run tests, build, all that stuff. There were some clunky bits that were kind of awkward with all these manual scripts. Everything is so much faster and nicer to use if you want to contribute. You can literally just pull it down, run the commands. There's no weird like, oh, you have to build before this. Turbo repo takes care of everything for us. I've been super stoked on this change, and that was a big one that came in here. So thank you, Milo. And there was a few small features, like things people probably have been asking for forever. As everyone knows, Solid has a children helper, which helps you get the children if you need to process them specially. So you might be like C equals children props.children, right? In a function. And this will kind of like deeply resolve the children for you. And actually, I'm on 1.4.1, so I can't show you here. Let me hack the URL so I can get the latest. Now, the thing is, if there is a single child, what ends up happening is it's just the value, and if it's an array, it's an array. But now, if you want it to always be array, you can just go, sorry, the types aren't updated in here, but you can actually just call toArray on this thing, right? So you can either access the children directly like this, or you can call toArray, and you now will get we'll get the children as an array. And just in case you don't believe me, because TypeScript, we haven't actually updated this. The release just came out today. We need to get this updated. There is actually some simple array handling. Just a small thing. People have been asking about this a lot recently, porting React libraries. They're like, how do I simply move the children to an array so I can iterate over them? These patterns all work in Solid, even without a DOM. There's just some subtle differences. TypeScript stuff has definitely been a lot on our mind here. So there's something called Node Next, which I knew nothing about before this release. But again, this is another place where someone from the community came in and basically updated everything, added extensions everywhere, explicit extension export fields across Solid and DOM expressions to support Node Next, which is the new kind of TypeScript resolution. So, yeah, I mean, these things are just they're small things, but they're really nice things that make stuff, easier to use. And actually, while I'm on TypeScript, we're going to nail off one more feature before, which is actually probably one of the how should I put it? One of the ones that I actually thought was worth highlighting on the release notes, which is keyed control flow. And some of you might be like, well, what? Why am I thinking about keys again? I thought you didn't need keys in Solid, right? And the answer to that question is actually a little bit more involved, but the simple thing is the reason you don't need keys in Solid is because we use mutation to update things. So we keep static references. So you don't need keys because the actual instance of the thing is the same. But there's two different behaviors you could have with conditional. Like, see this conditional that's in front of us right here, where we go show when there's a user and we have a div with a username. I think that's pretty straightforward scenario. You expect when there's no user that this doesn't show, but when there is a user, this shows. The challenge here, though, is, and this doesn't come up too often, there's two different ways you can update this in a fine-grained system. In a VDOM system, you don't care, right? You'll just re-render, like when this changes, you're going to re-render the children every time anyways. You just re-render. But when you have a fine-grained system, you could either re-render the children every time like a VDOM, or you can just only update the fine-grained bindings and update the specific places inside it. So when user changes, you actually only care if it goes from true to false, not if user changes, because user is bound here, maybe it's bound somewhere else. Those will independently update anyway. And by default, that's how our show component works. It only cares if it switches from truthy to falsy, and every little piece updates independently. But there are use cases where you want to quote key it, so recreate the DOM nodes when you go to the new area, and like whenever the user changes. And people have asked for that, like, do you have a keyed component? Well, the truth is, show has always done that through the form of a callback like this, where you can tell this user is just the user passed in, and whenever user changes, it just reruns this function, which means it recreates this div and reevaluates this. And because this user is coming from here and it's not a function, it could never update independently. It's pretty clear what it does, and it has one other really nice benefit to it, which is here that it's resolved. Like, because of the way this sits in, TypeScript has no way of knowing that a user here is resolved. Like, I could probably show this very easily in the playground, but this is going to complain at you because they're going to be like, I don't know if there's a user, because it's possible for user to be undefined. Being inside here, TypeScript has no knowledge, but here we can actually type user to be like, look, user is defined. So a lot of users using TypeScript were using the callback form just so that they can save themselves from putting exclamation points in. And that works, but that's not great because we just talked about it. Do you actually want to blow out the children every time? Like, do you actually want to recreate all these DOM nodes? Most of the time, the answer to that is no. And while this was a really reasonable split from like a normal standpoint, because like, again, you would only ever really want the callback in this form if you were keyed, and otherwise this is just shorter and nicer. Why wouldn't you do it that way? TypeScript makes us completely change what we want to do, essentially, which is a very common theme with TypeScript. There's benefits, but it sometimes likes to kind of like get in your way when you're trying to like design clean APIs. And the way we ended up actually, that someone's mentioning in the chat here is, pass render. Render props, right? Well, render props is the only way for us to type narrow here because there's no connectivity between these two things. This has been my philosophy. Unfortunately, it's not good enough at a certain point. People really people into TypeScript. This angers them furiously. Like my early take to API design was like, make something that is like good. Like look at it, work through it, and be like, this is something that is innately good, and then try and do your best with TypeScript. I was never willing to suffer TypeScript for API design. I'd never make something worse because of TypeScript. Over time, I've realized that the better way to do it is make the good version and then make the TypeScript version. And that way, people who are willing to go through those hurdles can, because they get benefit from it. Like there's no denying the benefit of TypeScript. It's just like, there's only so much we can do. Like TypeScript just can't do everything, right? Like, so like, it is what it is, right? So yeah, I mean, what we've done in 1.5 is add this keyed prop, and what it does is say, yes, I want this keyed. I mean, if you think about it, this is a better API anyways. You're explicit. You're like, when I want this keyed, I want this keyed. So you can now make it keyed, and whenever user changes, it will re-render this whole thing. Well, it's kind of wasteful, or like as I said, sometimes that's desired, but now it's explicit when you want it. And similarly, for the callback, we have this. Now, my challenge here is that we don't want this change to be breaking. And there's a reason why I went this approach with keyed, and I'll explain it here, is that with a callback that passes a function instead of just the value, it is possible to have type narrowing via a render prop in the same way this is, and have it update fine-grained. It can still only run the function once, but now that you have an accessor in here, you can actually, it can type eliminate the faulty values. So, you can use your TypeScript, what's it, make your cake and eat it too. But the problem is, we think callbacks are always keyed the way Solid is right now. So this is kind of a preemptive approach to it. Today, callbacks are always keyed, and I can't break it, right? If I tried to add this function, things would go bad unless we added other prop tricks, and it's a nasty business. But what we can do today is, if you go and try and use a callback because you're a TypeScript user and you think you want the type narrowing and you don't put the key property on, we can yell at you and you can be like, oh, I have to add the key property, which I'm hoping discourages you or makes you realize that you're actually opting into something, a behavior, right? Like go, oh, by doing this, it is now keyed. I have to actually consider that. And eventually, when we can do a breaking change, we'll add the callback that's type safe. You can still, as I said, always just put like a question mark or an exclamation mark here. But as I said, from the perspective of, it's kind of like a TypeScript purist, here's a solution for you. And it makes sense. Sorry, refresher again, I think that's a fair question. I did explain it a minute ago. What keyed does is saying, key it specifically to the value. So re-render the children whenever this value changes, which is slightly different because on the normal operation, it's whenever it changes from true to false. Keyed is actually saying like, no, going from user 1 to user 2 means I want to re-render this. Which is it. It's not the most common case, but it is an important case. So yeah, does anyone have any more questions like this? On this, sorry, specifically? I think I just wanted to show, because TypeScript is always kind of there and something we always have to kind of be aware of. And honestly, everyone knows, like most people know that I usually kind of avoid it. The last 3 or 4 months, I haven't been. I almost start every new project in TypeScript. And the reason for that is I think it's fair to say that as an end user, like as a developer using TypeScript, it's a lot nicer than being a library writer. And other people have said this before, but like if I start a project and the types work and I kind of do it, and like if something doesn't work, I just go like any and move on. Like especially if I'm making quick demos. So it just helps me a little bit. And when stuff doesn't work and I'm frustrated and any doesn't work, I can always go as unknown as any. Like there's like it's not going to end my day. I can keep the red squiggly and move on. On the library side, you don't get to do that. Your types have to be correct, and it's like this constant thing, right? Like I think I showed once that at a certain point, like half our PRs are TypeScript related. That's either just suggests how bad I am at TypeScript or just like how nuanced it is to get the right types. So yeah, I just wanted to kind of throw that out there just from a perspective side that I am, as much as it might sound like I'm kind of anti-TypeScript, it's more that I just don't find it enjoyable. But there's a certain practicality of it, and it has been affecting how I've been writing Solid. As you all know, we did convert Solid to TypeScript back very early on, I think late 2018 or in 2019. So Solid's core has been written in TypeScript for, I don't know, 2-3 years now. So there's it's definitely something we consider. It's just, I still try my best to make the best possible API and then think of TypeScript later. I know some people will say TypeScript will help you build better APIs. I call BS on that, because in some ways you can make clear APIs, but it limits, you're already putting a restriction on what you can think, like what you're capable of doing. You're applying these assumptions, and I don't like how that gets in the way of innovating. But like once you get there, reconcile it and figure out what you can do with it. So, yeah, there's a lot of open issues related to JSX and stuff on TypeScript. You can read them when stuff comes out. I think one of the ones that really have been challenging for me is the one that you return JSX is always JSX element. You can't like make a div, which is like, think about how much that unlocks for us. I'm hoping one day, right? Solid continues to get more popular, other solutions get more popular. This is sort of an inevitability, but until that happens, we just have to kind of be patient. Okay, so yeah, is that it for my little bit on TypeScript? Was there any other quality of life things? Oh yeah, some small stuff like the in operator, let's do something like this. This now can be reactive in our proxies. And Solid now, if it sees an in operator inside like the JSX, will actually recognize it as a reactive expression and wrap it properly. So again, these are just niceties that come as you use Solid and you realize, hey, there's new patterns we can build. I love this because when you give someone a bunch of primitives, like they can kind of build anything on you. So yeah, this has been really kind of fun. And a lot, what's cool about all these quality of life improvements is almost all of them, except for the keyed control flow one, came from the community making the PRs and doing the work. So big on people getting involved and helping making this release what it is. Okay, so should we get into the guts of things? How are you all doing now, chat? This is the light topics. I want to talk about it. I want to talk about the big topic for this release. What do we got here? Types are great until I need to change types themselves. Yeah, or types are great until you need to change TypeScript itself. Maybe that's a better quote. I guess that doesn't happen for people as much as it happens for me, but the prospect of having to change TypeScript comes up like every day or every week, it feels like. A lot of just random people asking about SolidStart. I did do a stream about this. Do check it out, like SEO and SolidJS and all this stuff. Yeah, like we have SSR and stuff, and I'm going to talk about SSR improvements a little bit later in the stream. But yeah, I mean, Solid is, a newer framework. There's probably some rough edges, especially on some of the newer features. But generally speaking, it's a fully featured framework capable of doing anything you can do with React or Vue or Svelte or any of that. We might be missing some third-party libraries, but like, if you can do it in them, you can do it here, pretty much. CoffeeScript for the win. Yeah, we managed to get here without talking about CoffeeScript. Man, it's like the opposite world. But it was fun. Anyway, okay. So let's talk about the big one here. Let me throw a banner here. Here you go. For reference from earlier in the stream, let's talk about the new batch. Yeah, I definitely missed an opportunity there. Batching, the funny thing about this topic and the new batching, which is, like I said, the core feature here, is I'm hoping that after I do this stream and talk about batching, like we pretty much never talk about batching again. Like the part of the goal here was understanding how we can shift our thinking and to a point where maybe batching isn't something everyone has to worry about. That's really where I ended up. But I did not start here. If anyone follows me in my writing on Dev 2, one of the coolest things is I tend to write about what I'm thinking about, right? Like, and what's I'm actually working on at the time. I think there's a certain learn in public element to it that maybe not everyone realizes, but like when I read an article, it's usually incredibly relevant to what I'm working on at that time or what I'm thinking about. And this topic of batching is no different. I actually wrote an article a few weeks back called "The Cost of Consistent UI Frameworks." I've been staring at this problem for months and months and years, it feels like. And I mentioned it in here, but I posted something January 2021, so a year and a half ago or something, about how like every framework does this code snippet differently. And I think this is a kind of good insight into the frameworks because it reflects not just like some mechanical thing, but their philosophy and their understanding what change means in their in the framework, like what how they view the role of JavaScript and the language and all that. Someone was asking earlier about Svelte and stuff, and Svelte has a very different view of what the programming languages for building UIs are, and different goals for that, which is why I don't often compare Solid to Svelte, just because like they have completely different motivations. So like. Sorry, I'm just catching up on chat. Oh, okay. Sorry. Okay, cool. Anyways, what I wanted to kind of point out is that, yeah, React was 0, and just so people who haven't seen this, although I imagine a lot of you have, this situation has the three primitives, which I call like the three main building blocks of modern UI, which are the state or signal, the derived state or like memo, and the side effect, which we're going to read with a ref. And this example, like as I said, all frameworks have those three mechanisms, even though if they're hooks or reactive or svelte or whatever. And every single one gave me a different answer when used from an event. And yeah, I mean, this isn't. I've talked about this before on stream. There is something I do want to bring up in this is just the default behavior when you're outside of the normal flow of the reactive system. And one of the things that I pointed out as being important is that in React 0, everything is consistent. Because like if this was a sum, count, double count, and double count in the view, essentially if they're all 0, they're all like correct, like count is still double count and the view responds. And in Solid, if count is 1, then double count is 2, and then the view is 2, like it's consistent. But in the middle two, we lose consistency. And at one point I was like, okay, well, clearly React and Solid are the best ways to approach this, right? And sorry, that's my like strictly better kind of faux thing, but the reality is a lot more subtle than this. And essentially, yeah, like React, we really like consistency. Read the article for more details on this, but what I wanted to point out is this example is sort of outside of the reactive system. So the handling here, while interesting, things aren't actually as different when you get into the internals. You like at a certain point when you're inside a framework, you're gonna have to decide. You're gonna have to update things, and code runs top to bottom. Like you know what I mean. Like code runs like in a sequence. At some point, things are gonna be inconsistent. Outside of the system, should you be able to observe that inconsistency? Was the question here. That's all I was asking. But more interestingly, internally, obviously, if you update some state and then some derived state up before that derived state updates, it's going to be out of sync. And before those effects run, well, that's going to be out of sync. This is just a natural evolution of or sorry, not evolution. It's just a natural flow of things updating. So the only guarantees we can keep are things outside of the system. And I want to make it clear, Solid's new batching behavior right off the bat does not change this. Nothing in this table actually changes for Solid's new batching behavior. But the reason I wanted to talk about this is because of the non-default case. Like, what if I had more than count I updated and I wanted to update like count 1 and count 2? I might not want to run everything twice, like the way I do in Solid. It's not bad in Solid because Solid, as many of you know, does fine grained updates. So if one cell has count 1 in it and one cell has count 2 in it, and you go count 1, count 2, like there's no overhead. Like you can, but if somewhere those converge, then in this situation, there's intermediate results, right? Count 1 is 1, while count 2 is still 0, and so on. So there are situations where you want to group changes together. And the truth of the matter is, inside the reactive system, we already do that. The only reason that Solid has this behavior is because it runs synchronously. And because it runs synchronously, there's no opportunity, except maybe intercepting the click handler, to insert the batching ability. Whereas in some frameworks that run on microtask queues, they can batch automatically, because the first place you call count, they're like, okay, look, we're not going to run anything till later, so we're just going to queue it up, and then you can call 10 different things, and then later we'll do it. But because Solid's synchronous, you need to kind of manually wrap it, which is the batch function, which is where this whole conversation stemmed from. Now, if that makes sense, this whole conversation is not about is not about how things work inside the reactive system. It's about how things like event handlers or timeouts or async calls work. And that would have been the case, except for Solid did one kind of funny thing, which is a thing that broke things, is it batched all side effects, which meant that essentially, actually, I should actually explain this a little bit. Before Solid 1.5, even though Solid worked like this most of the time, when you entered a batch, it actually worked like React. I very much cared about this consistency thing. Okay, like, and I can show you what I mean in a playground. It's probably the easiest way to actually do this. So if I had two signals, and I'm going to go back to 1.4 here. Sorry, deleted the whole thing. Go back to 1.4. And, okay, well, there we go. Let's create two signals. And just to kind of show you what I'm talking about, I'm going to count 1 and count 2. I'm not going to worry about returning anything for the moment. Send count 1, count 2. And let's create an effect. And in our effect, I'm trying to think of the best way I want to show this. In our effect, I'm going to actually have to create a couple effects to show you what I'm talking about. We're going to listen to count 1, and we're going to listen to count 2. And I'm going to console log our effect. Okay, sorry, I probably should have set this example up before I even started here, but let's just do it, right? And I'm going to also do this a little bit funny in that I'm going to just use a timeout to start our things, because I want to show batching outside of the system. Okay, so we're going to set count to, and actually we'll give it a nice pause of like a second, and we're going to set count 1 to 1, and actually let's just listen to them both in the console log so we can see what happens. Okay, beautiful. Okay, so originally we're 0, 0, and then when we set count 1, this, hopefully you all can see this. Maybe I can make it a little bigger. But essentially, if in our timeout we set count to 1, it updates the first count, and it runs the effect a second time. And if I do it set count 2, you're gonna be like, oh wow, you actually ran this effect 3 times. Once initially, and then on each update. And this is where the desire for batching comes in, because if this was just somewhere else in the reactive system, like I'm gonna pull this other one in here. Let's call it create computed. If I just made this create computed, though I guess create computed, well, let's see what happens. This is a little bit, yeah, that's too quick. Yeah, okay. So this is one of the challenges here, because once you're in the reactive system, everything's batched and it's optimized. So it's hard to show the, okay. So, but my point is, at a certain point, you're like, okay, well, I don't want these to update separately. So you create a batch, okay? And now when you create your batch, create batch, or sorry, what do I call it? Create batch, just batch. When you batch it, you'll see that it now applies both these changes at the same time, right? That's like the basic scenario here, right? It applies them both at the same time. But what I wanted to kind of show out is, if we read count here, actually, I can just pull it all the way to the bottom. If we go console.log count 1 and count 2, and we kind of do something like this. Let's call this timeout. Sorry, there's like a half. What you're going to see is the effect runs, then timeout runs, and the values still haven't updated yet, and then the effect runs with the values. If I pull this, actually let's call this batch. If I pull this outside of the batch, like after here, and call this timeout, what you're going to see is effect runs, then batch runs with the old value, and then at the end of the batch, the effect runs and you have the value, and finally the timeout console log runs with the value. So it runs synchronously. Like at the end of this batch line, everything is updated, but inside the batch, the values haven't applied. And this is essentially why batching is a thing. And what Solid did was it auto-batched effects. So it pushed basically held the values of the signals till all the effects had run. And this is good in a sense, because you really shouldn't be writing signals and effects too often. But it was kind of awkward when you did. And the problem is, with immutable data, it's usually easy to represent stuff as separate independent changes, like these counts are separate. But with mutable data, I'm getting kind of full circle here, we actually hit a really weird problem. So this is what I wanted to kind of show here, and which I had there. This takes a minute to kind of wrap your head around, but pretend you had an immutable array. So, and actually, if anyone have questions so far, I realize this is a lot. Let's see. It's like, oh, okay, yeah. So these guys are going. I've talked about these guys are going back and forth about reactivity. As I said, we started the discussion on reactivity for Solid 2.0, and there's like a debate right now about the best way to model some stuff. We're going to get there actually a little bit later in this explanation, but what I wanted to kind of show here with this example is that. Sorry, and it's this example I want to show here, is that if you have something that's like an array that's immutable, picture you have an array that's ABC, and you want to perform two operations on the array. You want to remove the item at the first index, like maybe remove item, what is here? Maybe remove item B or something, and then you want to take that removed item and put it at the beginning of the list. You have to do two operations, right? If this was immutable, you would just return the new cloned object, right? You would like if we had let me just find some space down here. If you had an ABC, right? Const list, and you went like A, B, C. If you wanted to like grab like. If you want to do this move operation with the mutable thing, you'd be like, okay, well, actually, I'm going to, I mean, this is kind of messy, but you could basically go take list 1, put it there, and then take the, I'm trying to think how I mean, you kind of get, I mean, the proper way would actually involve like a bunch of slicing and stuff. I don't feel like doing that right now, but like you could picture, you could just rearrange the order of the list. And then if I console.log new list and new list, you're gonna see, maybe I should turn off our time mode and stuff for a second. You're gonna see like what you expect, because you're always setting a new list. But when you do mutation on a list, it takes steps. You're gonna splice out the piece that's missing, and then insert it in, and it could be a push or an unshift or something. But I just took this example. But if I take this here and do this with a mutable list. So let's go mutable equals ABC. Then we get the move, and then mutable splice. You notice we never we never make a new list in this example because we actually mutate the original list. What you're like, you can see that you get the right output, right? And this is a common pattern, like common thing. When you have immutable data, you're kind of pushed to expressing all the changes as a single operation. It's kind of also why maybe batching isn't as important, because you'll tend to represent things as a single change. Okay. Now, but with mutable data, you're like constantly like it's sequences, because you're changing this and moving this. The order of the operations matter. If you add something, it can change future moves. And this is really awkward if you're in a batch. like our create effect was. Because what would happen, and this is the bug that showed up right away, is someone did this example with this thing that's designed to be mutable, is it would splice out. So it would go, okay, I'm going to queue up removing the item, but it actually grabbed the item. And then when it went to do the second change, it was like, okay, well, I still haven't applied the first change, so I'm not going to apply the first change. I'm just going to take that item and put it at the beginning. So what we end up with is BABC. Essentially, the first remove operation never happens because we kept the value in the past, right? And if that's not clear why that happens, let me show you subtly different, but it's the same idea. If I bring back our example here, and instead of setting count 2, I set count 1 twice in our batch, what ends up happening is you don't see the effect of count 1. It's as if count 1, like setting count 1 to 1, never happened, because it only needs to apply the last change if you keep things in the past. Every subsequent change just overrides the previous change. That's how React and keeping things in the past works. So like it's innately broken for things that are sequences. So like, as I said, I was very proud of the fact that I like fixed concurrency and all this stuff. And I basically had alienated these kind of create mutable things. As I said, I never used create mutable, so I never really thought about it, unfortunately. But this is kind of the problem. And I think it goes further than this, because as a person using these APIs, if I go back to this example, if it's fine because I called out this batch, you get it, right? The default behavior is nice. But what I was trying to get at is if this instead was in, let's like put it in an effect or something. Okay, so let's get rid of the batch. And now this timeout has no meaning. And this was just in a second create effect, okay? Right? If I did this, Solid 1.4 auto batched effects, which meant that, sorry, I need to, that this in the past behavior here, you were opted into without actually calling batch yourself. It's a good default. It makes a lot of sense, but people like were not ready for this because they're just writing some code somewhere, gets called an effect, doing some reactive stuff, and it wasn't. They're like, why is this the old value? Didn't I update the value? As I said, this is really good because it's consistent. If we added double count in here, yeah, count 1 times 2. And let's get a memo in here. Create memo. If we added double count in our thing here, what we're going to see is double count is still in the past, right? Our effect runs 0, 0, 0. Yeah. So this is kind of consistent, but kind of counterintuitive for a lot of people. And it doesn't work with mutable data, period. And I started having to ask myself, like, how much does this actually matter? Like, this is really, it's very unsettling to go between something that like updates automatically and then suddenly something that doesn't update. Like this inconsistency bugged me. But like, I could argue that it was consistent. And the thing is, with a reactive system, we even without this hold the signal rate mechanism, we already have batching built in. And this is kind of the funniest thing about this, because the truth of the matter is, you don't, in this situation here, I mean, this is not very deep, but you don't necessarily want set count to update immediately before this next line. Like, you do want these batches to happen naturally. You just don't want to see the old value, right? You like, innately, you're like, yeah, I want these both to apply at the same time. And because sometimes you can get some weird infinite loops where you trigger something for set count 1 and it like changes the conditions of what this effect is running on. It might even cue this effect to run again before it's even gone to the next line. That would be bad. We do actually not want things to always propagate immediately, because you get really weird place. You want your code, while it's executing top to bottom, to be consistent. And for that reason, at a certain point, I kind of gave in, and I realized that we didn't need to keep things in the past really for any particular reason. And while I don't care about create mutable, I don't think people should be using it for the most part, there's no reason for it to break. And honestly, sometimes when you're doing stuff, you do think in sequences. So let people operate in sequences. And the funniest thing, and I'm going to explain how this works in Solid in a second here, but if I go back to the code to actually implement this, where was it? Simplify batching. Where's the original one? Sorry, give me 2 seconds here. It's right at the beginning here. I actually did this as 2 versions, because when I first tried new batching, I was like, oh, I should, maybe we should do things like Svelte does, like make it inconsistent so that the initial values update, but everything stays in the past. But what I want to show you and really highlight, which is kind of funny about this PR, is, or sorry, this commit. Sorry, I'm in the test file. Where's the signal file? Yeah. All this PR does is delete things out of Solid, for the most part. I mean, these lines change, but if you actually look, the replace line's simpler than what it would left before. I just went in and deleted the batching stuff. Solid's underlying system actually already, to basically get the behavior everyone wanted already, I just needed to delete stuff. I just make Solid smaller, for the most part. And the funny thing is this first PR got us to Svelte level, and not PR, this first commit, and then our next commit, which happened a little bit further down here, I saw it a minute ago, something about batching, probably should have continue to delete more stuff is what I was trying to show. Basically, all we had to do to get what we were looking for was actually delete a bunch of stuff out of Solid. Actually, like, make it smaller. And yeah, and let me show you what the key difference is here, because we were holding the values. We had to make a construct to hold the values, and it isn't really necessary because of a couple things. So I'm gonna pretend to share this link, which should hopefully, I'm gonna save this just in case it doesn't, allow me to change this to 1.51 and show you what happens now. Basically, the batch now is observing the latest values, and we basically just went straight to where we needed to be. And it's not just create effect; it's actually the batching in general. There's some subtlety here, but I want to show you something that's important. The reason that we can do this and React doesn't do this is because we use getters. Because we use getters, you don't have to worry about this not being updated. We can both apply the change at the end and eagerly evaluate any derived data without it being inconsistent. This is Vue, but it was also always solid. It was just solid, how solid worked outside of batching, but inside the reactive system. I realized we just had multiple batching systems, so I just deleted one of them. That was the revelation here, right? Because solid already has this ability to evaluate. And let me put batch. Let's go back to our set timeout so I can show you this a little bit better, because I think the set timeout better is more visual. I just want to show that in effect this works fine. But if we bring back our batch, right? First of all, there's no need to put this here because it's already updated. But I will anyways. But the reason I want to kind of illustrate this more in steps is this is actually, you know what? I'm gonna show you. This is how we're gonna do it. We're gonna console log in the memo. It's a little trick. We're gonna console log inside the memo to show you what I'm doing. Again, you shouldn't do side effects in a memo, but let's console log inside the memo. So look what happens in our system here. I'm gonna remove this one so that I have less noise. But what you see happen is the memo runs the first time, and the effect runs, and then when we do the timeout, again the memo runs, and then the effect the effect runs. So this, you might be like, okay, no big deal. But look what happens if I remove double count from here. This is important because it goes memo effect batch or memo effect originally, and then we do our timeout, and then our batch goes batch memo effect. If you notice, me moving the double count in, and I'll put it back in again for a second, actually moved where the memo happened. When I put it inside, it actually ran before the batch command, and when I deleted it, it ran after. And the reason it runs before the batch command is it's literally running right here in line when we're asking for it. So you can't console log until this has already ran, right? But when I get rid of it, it runs at the end of the batch like everything else. So it runs like basically just before the effects run. So what we can do, basically the reason this whole mechanism works is we can defer executing everything in a batch unless you ask for it, which means we can always show you the latest value if you ask for it, because we have this push-pull ability. And I can explain a bit better what that means, but essentially it will run eventually anyways. But this way, if you choose to opt into reading stuff ahead of time, we can preemptively calculate it for you in the case of things like memos, because memos are derived. So we know the second you set this signal, even if we haven't propagated the change, we know that that this memo is out of date, and that the next time you read it, you're going to have to recalculate it. Right? So this is why we didn't have to be too hardcore on this. Even with stuff like transitions, suspense, and concurrent rendering, because we already fork, and this is more technical, fork the reactive graph, it's okay to be like this because those eager values they're already forked. They're not gonna merge with the existing graph. So like essentially, we can do this eager thing. And to be fair, there are cracks in this, in that if you go back to my original article that I was showing here with the cost of consistency, you're going to see view when you're inside the effect, like while the reactive system's running. Because like while you're in that batch, one runs, you're asking for two, so it calculates, but until the end of the batch, we can't possibly apply the DOM effect, right? So when you're in a batch, it looks like this, and when you're outside of a batch, it looks like this. But the funny thing is, in reality, inside a batch, if you don't ask for it, it's actually like this. It does the least amount of work up front. And this has huge impact. As I said, most of the work here was deleting code, but the bigger thing here is people were batching before to try and do things like, okay, I want to apply these together and do. The only place you need the batch is in that set timeout or callback or whatever. Like essentially, you can now pretty much forget that batching is a thing for the most part, because in the simple case, like the create effect I showed you before, you'll just do stuff, and then if you read double count, well, it'll be up to date. You don't have to worry about this. Yeah. So someone's asking bidirectional reactivity. Yeah, it's called push pull. Is kind of like technical thing, and I did not invent this. This is how MobX works. And it's actually quite clever because what push pull does, and I'm gonna open Excalidraw here. It's probably got some garbage on here. I don't even remember what this was. You guys remember this stream? I don't know. Looks like some out of order streaming thing, but the whole thing with push pull is that we mark the reactive graph before we actually apply the changes. So like I'm going to go left to right because it's easier, but I'm just going to pretend like we have some kind of graph here, and we're going to kind of branch out. I always like doing branches, but we'll probably only follow one branch out. I'm just going to show some kind of propagation. You can think of the start of the propagation as a signal, right? Like the thing that's sort of unwritten here is, and again, these don't have to be perfect lines, but essentially, more than often than not, you've got like these kind of three zones, and this I'm stealing this straight from MobX. If you go find a Mikhail Westrate article, you're going to see this like immediately on any of this, right? Because this will be like signal, and then this will be memo, and this will be, let's say, effect. It doesn't have to be, but like this is essentially like a representation of our reactive graph. And like, to be fair, this probably, it's kind of like something like this. And all we need to do essentially is kind of move when someone updates this, goes like, hey, this thing's updated. We just kind of move through the graph, and I guess maybe color selection is the best way to handle this, but I'm going to be doing a lot of copy and pasting, I guess, to kind of work our way through it. We have a video, so we can do this kind of live. I don't need to produce artifacts, but essentially someone goes in and goes, okay, bam, we update this, right? Next, I'm going to use orange, okay? Can everyone see that? Maybe I should make the lines a little thicker. Okay, and someone's updated the signal. At the second that the signal updates, we know that this memo needs to reevaluate. We know for sure this thing is dirty. So let's do that, and this one too, because this is definitely updated. This is now dirty. Okay, but these ones we don't know, because the memo could evaluate to the same value. So for these ones, suddenly, let's make them kind of like a greenish color, okay? And do this, okay? And oh man, you're gonna get me into an argument on stream, aren't you? I strongly disagree with this, but we'll get back there. Okay. Essentially, with this kind of propagation, we mark the whole tree, and what's important about this is even if we do something like go depth first in our decision, I don't know if I should actually use memo effects here as an example. I wanted to show that there's layers, but the truth of the matter, this only gets interesting if I do this actually and make the memo layer a little bit more complicated and maybe put an effect out here that listens to these, because actually I'm gonna take a prop from Milo, who made these boxes. What I wanted to point out here is at this point, and actually this box can be green, we don't know if these actually need to update. Okay, but we know that these ones definitely do. And if we take something like a depth first algorithm, and I mean you can pick which side we traverse first, we can actually, like the signal itself gets updated, it's fine, but then we can like run this one first and it goes, okay, I need to rerun, and on it updating, like realizing that it gets a new value, let's say if the signal went from 0 to 1 like our example, it goes, hey buddy, you need to update, right? And we're going depth first here. When we get to this guy here, he's going to be like, okay, well, I need to update. But when he runs, and you can picture this like this grid, like if you need a visualization of what's going on here, picture this as some signal S, and I'm going to make this black. And then these are memos A, B. I'm doing it upside down for most people probably, but what I wanted to show is like something that looked like this would essentially have essentially B or A equals some function of S. I know I'm getting into math terminology here, but then C here is actually some function of A and B. So a lot of times when I do these, I just skip the function of and just go like it's A plus B, right? And this is just derived from S, okay? Now, what I'm getting at is if you have C equals A plus B, and A is updated because we went down this track, so it's in black. So this is now 1. This is now 1. But B is not 1 yet. It's still orange. So it's still 0. When you get to C, if you're not smart about this, you're gonna go C equals A plus B, and you're gonna end up with 1, which is not the right reality you want to be in, right? What you want is you want to go, oh, so what we actually do in a system like Solid is when we go, in this case, we know we have to run C, so we're going to go run it. But when we get to A, we're like, okay, yeah, no problem. A, get the value, get that 1. And then when we get to B, we're going to like, oh, B, you're out of date. You better run. So while we're in the middle of C here, we, like I showed earlier with the double count, that's that same kind of pull mechanism. We essentially go, okay, let's evaluate this right now. So we solve it. We make that now is 1. And then C is like, okay, good. Now you're up to date. I'm going to get my proper thing of 2. Sorry, when B updated, it also set this one to to orange as well. But you can kind of see how this propagation works, right? And I mean, it can be a little bit more complicated than this, because sometimes this arrow isn't so direct. Like sometimes this arrow isn't here, and sometimes there's some other convergence. Basically, there's all varieties of diamonds you can make when you're playing with this, right? But once you have like a degree of separation, you can see how this gets a little bit more complicated. We're gonna do one more example here. So I'm resetting the board so you can get it. But I'm hoping after this example, Solid's reactivity will make a little bit more sense, and we can kind of move on from this whole batching thing, right? But all right, let's get all the way back to the beginning. These are all black. These are all black, okay? And I'm just gonna put another little circle in here. Let's add E to our equation. All right, you all still with me? Someone's asking if this change affects any benchmarks. No, that's what I'm saying, because all this stuff only affected things kind of like outside the reactive system. Like if you're writing signals from effects, which never happened in any benchmark, or if you're like writing stuff from event handlers where you're introspecting values. So basically, this was just simplification and deletion. So me spending this much time on this topic is probably unwarranted, because you guys will just be like, oh yeah, so everything just works, you know, and forget about it. But I think this is an opportunity to actually explain reactivity a little better, right? So like, let's run this example one more time, and kind of you can now picture that this C is just a function of A, and the actual interesting one is E, which is now a function of C and D, right? Right, and I guess I'll just add this one back up. What was it? C is equals A. I'm just doing one layer. I'm going along the bottom here. Yeah, so okay, so let's just run this, right? So update our signal to 1. See, this stuff would be good for like the old RxJS style like diagrams so people can see change propagation, but update to 1. You are now invalid. Okay. And you notice we only have to do this dance on signal write, okay? So we actually go all the way through. So there's definitely need to work, maybe need to work. Like we don't know these ones need to rerun, but it's important because if you go up this chain, right? So like if we set 1 and then we're like, okay, so now we need to recalculate A. So A becomes that and A gets its 1, right? We're just doing a straight pass through. This now becomes orange. But you notice something here, like this example is a little bit different this time, because now, okay, we're like, okay, done. Now we run this one, because as I said, we add them depth first. So we're actually going A, C, E, B, D. So we go here, and you might be like, why do depth first? Breadth first would probably solve a lot of these problems. It would, but when you write code the first time, like think about nested things, like components and components, or like even this console log, like the children, you essentially have to be able to, like everything does execute depth first, right? You hit what's ever inside this line before you hit what's in this line. So if you want to maintain that consistency, you actually want the reactive system to also propagate depth first. So in any case, where am I going? Oh man, there's so much discussion going on in the chat that I want to like jump in on because it like lacks the cross framework nuance element of it, but we'll get to that in a minute. Anyways, so we have C here, and we're updating it. So now it goes black, and we know that this one is now orange. And now we go to update E. And E knows it has to rerun, right? When E goes to rerun, it gets C and it's like, okay, cool, C's 1. But when it goes to get D, D's like, I might be okay, but I actually don't know. So we actually have to, D has to like actually go back up here and go, okay, B. And again, we can do this with derivations because we both know what listens to a memo and what it depends on. We can actually walk up the graph and be like, okay, let's go back to B. And B's like, okay, yeah, I definitely need to run. So B runs, right? And B gets the 1. Now, at this point, D becomes orange, and then it runs, and you can see how it funnels in, and we get the right value. But it's more interesting if the situation around D was like only if it was conditional. Like, what if D actually, or like what if one of these actually didn't need to update? In that case, we're still good. And I guess the best way to show this, I said that was the last example. This is going to be the last example, I promise. Is what if C is some kind of conditional? Like C basically goes only update it if A is bigger than 1. Otherwise, keep it at 0. Right? So if C was like, nah, we're going to return A, if A is bigger than 1, then we're going to return A, otherwise we're going to return 0, okay? Right? So basically, C remains unchanged in this scenario. If we actually did this propagation, and we kind of get back to where we were, where I'm kind of rewinding it a bit, but where these are all green still, right? And we get we just finished doing A, so A marks this one as needing to work. So I kind of rewound to this point, right? And if we got to this point, right, and C evaluates and C goes, okay, A bigger than 1? No, A equals 1. Okay, so I'm going to stay at 0. If C doesn't update, it's just going to go black. And it's not going to notify this one. It's going to stay green. At which point, E doesn't need to run. E doesn't know if it actually needs to run. So we end up doing is going back to B, and working it out that way. So I mean, there's some subtlety here. Actually, I guess that's not true. Actually, sorry, I'm confusing it again. But it's interesting because you can get to E, and before you run E, because it's green, it knows it doesn't. Let me correct myself. Because it doesn't know it needs to run. It asks the question like we did a minute ago. Like it goes up the tree. And if by chance D is the same, and I hope this makes sense, this one could go orange. Depending on if this one actually successfully updates and makes this one orange, then E will run. But if this one also bails out, E will go, okay, well, I asked everyone and nothing changed, and it just won't run. So we have this ability to stop the propagation anywhere along this tree. And I'm sorry, this is very technical, but this is probably maybe the last time you're ever going to have to worry about this. because this behavior happens for you automatically. But if there's any kind of takeaway from this 1, 2, 3 thing, is Solid very, very, very clearly here has an update stage. It has a pure computation stage, and it has a side effect stage. And these things are actually clearly scheduled. Right? Like there's clearly like 1, 2, 3. And the reason I wanted to show this is not unlike React, right? Because in React, and let's give ourselves a nice React blue here, you're still gonna like set state here, right? Do the update, and then you're going to go, what is it? View equals a function of state, right? You're gonna run all your components, and then you're gonna diff and patch over here, okay? These systems actually lay on top of each other with the same kind of split, which is really important because this is why we can do things like run all the pure computations and hold the side effects till later for things like suspense or concurrent rendering or all the things that apparently you can only do with a VDOM, because we actually have the same stages. So I think this is I think this is important to kind of talk about, because I was on Twitter and someone they'd released the tan stack query and they're talking about suspense and suspenseless, and Adam Rakis was like, what? Solid has this without a VDOM, blah blah blah. How is this possible? And it's possible because reactivity is like, it's like promises. It's a primitive, right? Like a VDOM is a system, like you're building a specific engine or building a specific thing. But reactivity is just a way of modeling something. Like, how should I put it? Like, go back in the day to something like Node, when everything was written in callbacks, right? And then someone introduces promises. Like, you can do all the same stuff without promises that you can do with promises. Promises just let us model stuff slightly different so that it like made it easier, because now suddenly our ability to kind of like pass them around gave us the ability to kind of make the async guarantees portable. But if you look at it, like, you can do the same stuff. And the truth of the matter is but if you've written your whole architecture on Node callbacks, then like doing that migration was actually kind of painful. Like, just because you kind of like had to like switch every place, kind of like invert the pattern a little bit. And like, there was nothing wrong with necessarily doing the callbacks, but suddenly promises kind of changed the way you could do things. And that's really the way that I look at reactivity and whatnot. Because like, you can build a VDOM in a reactive library. Like, it's just a representation. We don't need it. In the same way, once we had promises, we no longer needed, like, have any of you ever used Q or QAsync with the old callbacks in Node? Like, you had special libraries, or even like some of the cool stuff people are doing with generators. Not that generators are a bad thing. I'm just saying you basically structurally set up your program around these queues and had these libraries, and you made like the queue system was the base of it. I did this kind of development, and then the callbacks would all kind of feed into it, and that would be your architecture. But once you had promises, that whole thing just disappeared. You're just like, okay, well, I'll just use a promise. And that, to me, is very similar parallel here. There's no reason you couldn't do anything with a VDOM that you can do with a reactive system. The only challenge is maybe the differences and complexities of modeling it, and whether you want to take on certain kind of overhead. Because like a VDOM is like, yes, we need like the VDOM. We want to do this diff. Like, that's the assumption. The same way, like, It'd be like having callbacks with that queue library. You could always pass promises into that queue library. Like you can do that, but when you're like, well, I got promises, I don't really want to use the queue library. That's where the thing is. Like you can do it, but you're kind of like, I'm gonna try and avoid doing this if I don't have to. Not everyone's on that boat. Like Vue does both or whatnot. Like you can definitely put them together, but it's kind of like, do you really need it? And I don't know. If anybody's an old Node developer who witnessed going between callbacks and promises, I feel like it's the same kind of thing here. I'm not suggesting that promises and effects are the same thing, that like they're replaceable with each other. But more the similarities between using callbacks and promises. Once you have a primitive, that gives you this kind of power built in, it compared, like as I say, promise compared to callbacks, you suddenly can do more. Like you can suddenly go, oh, okay. Yeah, I actually don't need the model this way. It helps in the simple cases, it even helps in the complicated cases. It just scales differently because you changed your mindset. Yeah, I don't know. Sometimes I go on these little side rants and I don't know if they make sense to anyone. Yeah, so some of you get it. Man, there's this discussion going about like how close you are to the DOM or just JavaScript between VDOM and non-VDOM, and it's like, I think some people are just uncomfortable with compilers. I'm just going to address this one in chat because people keep on going back and forth with it. Okay, actually, sorry. Before I do that, someone's asking, can you please explain the difference between push and pull here? Yeah. Push was that process where we went forward, where we went orange, and then we're like, okay, you become orange, you become orange. It kind of pushes down the line. Pull is when we got up to E and we were like, oh, I don't know about you. Oh, actually, I don't know about you. And you went back, and it was actually from accessing the value that you're like, okay, I actually need to look up. I need to look up, and then you pull it up. And this is actually a big difference between like RxJS and like signals or like MobX style stuff. Because stuff like RxJS is push only. There's no concept until you get to like behavior subjects and stuff, but there's no concept in the basic observable of owning a value. An observable is an event stream. It's just a series of values. Doom, 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 doom. You never ask the observable what your current value is. It's like, what is current? It's just a moment in time. Whereas in fine-grained systems, which are kind of like synchronous by nature, the primitive, the signal, actually represents the value. In a sense, these names are almost reversed. I think observable is like a terrible name for a stream. And maybe signal is a better name for a stream. I don't know. But like, one intends to represent the value that it is, like it is the thing, and the other one represents the container. It's a very subtle kind of difference, and I think it even comes down to even some people's opinions on what naming and stuff should be around this stuff. But that's the whole thing. When you do a change and you propagate it out, that's push. When it kind of fans out, pull is when you're like, oh, this is stale. Let's walk back up and figure it out. Yeah, but the thing is, the reason you were in this, yes, it is eager versus lazy, but it's also because there's strictly pull-based systems and strictly push-based systems. I used RxJS as an example of a strictly push-based system, but you can look at React as a pretty much strictly pull-based system. It's not 100% true, but like when you rerun the component and then you check the dependency array to decide if you're going to rerun something, but then you each time as you run through the code, you're asking the question always. You're not like going like, I'm pushing this out to this specific place. You're just like, update this component and let's pull what we need to pull from it. So React is like very much on the pull side. RxJS is very much on the push side. Solid and Vue are in the middle. Yeah. So, yeah. Sorry. Yeah. Is there actually? Can you play some examples from real life? Yeah. I guess my examples with the stuff was not very clear with the equation, but it always gets harder to abstract it out. I think things like the show component are where you get graphs like this, are where like we talked about keyed and non-keyed earlier in the stream, and the way that something can decide, like the keyed versus non-keyed, is actually really important if you have a situation where, I mean, let's quickly kind of pull this out. But if you have a situation like, I'm gonna quickly just make a div here with a count in it, and luckily we already have our count one, so we can leverage this, right? This might not completely answer your question, but I think it's important for this, because to actually accomplish things like the show component requires this kind of knowledge. Because if you're going to say count one is bigger than 5, and now, to be fair, this will actually force us into a Boolean anyways, but you got to ask yourself, how do you isolate this change? Because if count is bigger than 5, show count. Okay, that's easy. But what happens when count is 5, 6, 7, 8, 9, 10? This statement is still true. If you reevaluate this every time count changes, like we need 2 memos. We need to actually split the graph, because if this side effect was just like, if you kind of naively thought about this and you're like, okay, well, I'm kind of thinking of this like a crate effect, and I'm going to go if count is bigger than 5, yeah, console log expense of work. Okay, right. Let's quickly. Yeah, I'm going to go back to not returning anything, and we're doing count 1. Actually, no, that's not true. I'm going to use a button. Let's get a button. Right, and we're going to say call it click me. Why not? And we're going to do something like on click. What is it? Set count 1. Can't see if yeah. Set count 1. Previous count plus 1. Okay. And maybe we can format the document, but it won't work because we're blowing up. Okay. And did I spell create? No, I didn't. I just put a const in front of it. Okay. Okay. So now when we click it, right. We also kind of, actually, you know what, we want to see what the count 1 is in the view, just so that we can, get some feedback on our progress here. So, okay, click me 1, click me 2, 3, 4, 5. Okay, so far so good. Now we got to 6, and we're bigger than 5, so we did our expensive work. Oh, we're still doing, every time we're redoing our expensive work. This isn't good. Right? This isn't good. Right? You can't just make a reactive system out of signals and effects, right? You would do stuff very wastefully, right? And even if you try and do smart batching and splitting, you're still going to get it's possible with a deep enough tree, kind of like what I showed here, where these are like different depths. Even if you try and group things together, like if I delete D, like that pulls E up, and then like even if you try and like use scheduling as a way to get around it, you're still going to do unnecessary work. So this is part of why memos are so important, because if you actually want to make the show component, you do this, const condition. This is all show is, honestly, like it's a little more complicated, but if you ever want to like, I always say, oh, you can just make your own control flow. It's super easy, right? We just need to extract this out. If you make a memo around the condition now and say, instead of this, check the condition. As we click, sorry, let's refresh that. Oh, yeah, I got create memo. As we click, and now it's going to go do the expensive work, right? But now because of the memo, it's only did that expensive work once, because this resolves to true, never changes again between true and false, which means that this effect never runs again, right? And kind of get back, and I hope I'm answering the question properly. This is why you can come up with some of these advanced graphs, because yeah, you could compress everything into the effect in theory, but that would be incredibly inefficient. Right? Because effects don't have this two-way graph. If you have more effects, you just have more effects. They're just like a line, right? You just they don't have this kind of depth thing. All they have is dependencies. They don't talk to each other. Right? How do we write the create memo function? That is super hard. This is the most trickiest part of the reactive system and the most important part. That's why I said like create memo is the reason why reactivity works today. MobX, that was the thing, because the basic version of this was like an effect writing a signal. That was like when I teach reactivity, I'm like, oh, just pretend like an effect writes a signal. But that is not sufficient here. Right? And it's not just to avoid effects, it's to avoid expensive calculations like other memos. Sometimes the other memos are expensive too. Right? The reason this system's so complicated is because like if they always updated, if there's no conditional updating here, like if C or D couldn't drop the line, then it would be a much simpler system, because you'd be like, okay, well, I know all the effects. Once I queued them, all these effects are going to have to run anyways, and then you can just pull the values and like you make the system much simpler. I think someone was actually showing that Vue. I said Vue was like MobX. Someone was showing me that Vue actually doesn't solve the diamond problem and actually it is inefficient in the way that I'm talking about here. I don't know if that's true. I haven't verified it myself. Someone was showing like, oh, Vue some example of Vue not solving the diamond problem. I think that requires verification, because I'd be very surprised if that was true. But this is why, as I said, memos are super, super important. And kind of like a piece of this puzzle. Like if you don't, like it's more apparent for us being a fine-grained library because we rely on this behavior. That's how we get every pinpoint update. Right. This is why Solid is what it is, right? And why React's memo everything. You can't remember the name. Seems like, well, the thing is, you don't. Do you know the power here is the explicitness. Like, you could also not, right? There's a lot of times where the memo isn't necessary, right? I like this control. React kind of gives you this control. I think when you go to a compiler, like one of the things I always talk about with Svelte or whatever is, without the ability to be explicit about these things, you can't optimize. Like because if every let is a signal, that's an easy one to actually optimize out of. But like then every let's a signal, and if every derivation's a $, then every derivation's a memo. Like you can't make that distinction and optimize for your situation. And in Solid, often I'm like, actually, guys, don't worry too much about the memos. Most of these things are handled in important pre-made stuff for you, like control flow components and stuff. You need to know this to write libraries. But if you're writing application code, you can base most of your own code probably, unless you need like know it's expensive, probably doesn't need memo. It's like the glue that needs to do the memoization. So we can set you up on defaults that generally are less overhead than just auto memorizing everything. If you have, could you have a memo that stays in an unupdated state for a while if it's not used, say used later in set time. Right now, no, but there's potential for this. Right now, because of this situation that I was showing here, where like it might never get to the end or whatever, I do have like this thing at the, like when you get past the execution, get past the batch, I'm like, okay, let's clear out the pure computation queue, because I want to make sure that like we didn't leave any loose ends. But it's because you have both ways tracing, and you could say like if something's not listened to, then it doesn't actually need to run. I believe doing the right stuff with auto cleanup, you could probably make a system like that. But I this is something I'm still evaluating. There's some details of Solid specifically that make me not as confident there, mostly because like I think in the pure reactive system you could, but in Solid we do other fun stuff with effects, like the concurrent rendering stuff, and that always plays into how we approach these solutions. Yeah, you just missed probably the most technical explanation part of the whole thing. So, yeah. So, yeah. I mean, the takeaway here is, I'm hoping that for the most part, none of you need to work. Now that I've explained how everything works, none of you will ever have to worry about this. That's why we did this work, because it disappears into the background. And I'm very stoked about that property here in terms of batching. But yeah, this was the big one, the one that required the full Excala draw. Yeah, I think this is, I was really torn, because I was like, okay, like part of me was like, maybe I want svelte, but this, because I don't like inconsistency, like I really dislike. I mean, it's funny, svelte is inconsistent, but it's like in a very explainable thing. But one of the biggest conversations we had was making sure that pure is pure. I don't know if this means strict mode in the future, if this means that Solid's going to go on a path where we live long enough to be our own villain, you know, like the whole like React thing, where it's like strict mode is too strict. But I think we really should get into a zone here where create memos, don't write signals, and that we can depend on this part of the graph being derived. Because as long as no chaos happens in here, we can make huge amounts of assumptions, not just for optimization, but like for consistency. All right, so how are we doing? How far are we in here? 2 hours in, wow. That was the big one. Okay, so we still got two big topics though that for the release. I want to talk a little bit about resources and SSR still. So let me see here. We can make a little thing here. All right, let's get back to our release page and let's talk about resources. There's no more questions here, right? Create signal inside of create memo. Yeah, we don't have hook rules, so don't worry about stuff like this. It's all just the same. When I say create, you could creating a signal inside create memo is okay, because you're actually like, it's a derivation. You're creating, like you're taking some data and using that data to create a memo. The problem is writing a signal inside a memo, because then you're like triggering another update. But actually creating one inside a memo is perfectly valid. To our benefit here, I don't think we have to worry about this too much, because I actually made another primitive called create computed that is set up to be clearly for this case. So people shouldn't be using memo this way already. Like I don't think this is actually a real problem. It's more of that people were using create effect or create computed, and the people using create effect aren't going to have a problem here. They might be doing stuff that's unoptimal, but they're not going to, like, it's not a big deal. People using create computed, we're going to move people off create computed in 2.0. And that was part of why I was able to do this batching, because once I resolved that, yes, we don't need to worry about the weirdness, then everything just simplified. And as I showed you from the commit, I literally just deleted a bunch of code out of Solid, and it's probably faster now and smaller. So this is from me spending a bunch of work and time to to maintain something for your sake, and maybe it wasn't needed. I do that a lot. Maybe go back and look at the stream a little further. The last half an hour I literally was just explaining how all this works. Yeah. Happy about this? Yeah, it's a good step forward. I'm glad everyone's happy about this. Okay, so let's talk resources. Resource stuff is actually a little bit more straightforward. The first one that's really easy, and again, a TypeScript thing that everyone's going to love because people love TypeScript, is that we're going to add a new state field to create resource, which means that all the 5 possible states are all representable here, like whether it's ever resolved the value, whether it's currently loading, or whether it has an error. And people love this with TypeScript, obviously, and I'm going to pull up, not the JS Framework benchmark. Why is the JS Framework benchmark like the only thing I have open? Actually, let's see. Do I have another one? No. New window. Let's open Solid here for a second to just show you what I'm talking about. I could just go to the repo, but whatever. Let's go to Solid, not SSR, source, reactive signal. Yeah. What I want to show here is that is now with the resources. Because of this, we get to do fun stuff like this, where we create interfaces for each potential state, which are type narrowing. So essentially, if you indicate the specific string, we know whether the value can possibly be undefined or not, or whatnot. So this is kind of nice for TypeScript. The ironic part about this change is if you're using error boundaries and suspense, you should never use this, really. Like, this is really good for like people doing basic stuff, but error boundaries and suspense are designed to automatically handle this stuff for you on read. So I added this because it was very, very wanted, and it gives people more insight into what's going on, especially if they're not using these features. But like the golden path probably suggests you should never use this, because you shouldn't be the one taking care of like all these conditions. So anyways, it is very powerful though, because type narrowing is important. And just wanted to show that because like, yeah, the resource type literally just becomes a union of these different states. That one's an easy one. I think the most requested one is this one. How about resources that are stores? Now, I haven't landed on a final API here, and there's some interesting decision points, because if I made a create resource store, suddenly we have like a split where now whoever implements React or Solid Query or Turbo Query or whatever has to make this choice and like expose it to the end user and stuff. Like, do they have 2 primitives? There's this natural split on reactivity. So instead, as I said, this is kind of copying out, kind of doing like the experimental, unstable, whatever, like kind of thing. But essentially, I've created the ability for you to just pass in the underlying signal. And if that signal happens to work like a store, that's cool. What's cool about this is we'll be able to play with things and decide what kind of patterns we want to do. For example, in this example I gave here, I make something that looks like a signal, right? It's just grabs a value off the store and it sets it. But I create a store under the hood, and I actually call it with reconcile to do data diffing. So what this means is every time you, like, let's say you refresh a list from an API, and get the full list back, it will just data diff, and it'll be like, okay, bang, you changed only the completed field on to do 2, and then just fine grain update that instead of rerunning anything. It'll just jump through, and that ability for fine grain is super powerful. Like, don't get me wrong. Like, this is going to be part of SolidStart. Like, I showed that cool to-dos demo the other day using our actions and loaders. Like, we're going to bootstrap this in so that we can do the almost remix-ish if we want to reload all the data without re-rendering anything and still getting our fine-grained updates. It's super powerful. And for those who know, Reconcile has been benchmarked, and it's basically very similar in performance to stuff like Inferno, like the fastest VDOM libraries. So I think having this ability is really powerful. And it's people don't realize yet, and because I haven't wrapped this into like a nice like create resource, create store resource or whatever primitive, this one might be slow to catch on, but I wanted to show you guys, if in case you want to tinker with this and come up with ideas of how to mess with the storage on resources and do a lot of different stuff with it. I think this keeps the API really open. And as I said, this case, which is the obvious case, I'm already seeing benefits with the work we're doing on SolidStart. It lets me do smarter stuff, like that. If you did watch my stream, there was a to-do example, right? I probably have that like up here somewhere. Where was I? Yeah, like not the bear one. Oh yeah, to-do example, right? If without this kind of deep, fine-grained ability to do the updates to the resource, what ends up happening is every time you pull from the server, it's going to need to recreate that list item, which means that there's no way that the actions all have to be declared top level if you want them to kind of like be an overarching thing. As soon as you have this diffing, then this no longer becomes a problem, and you can actually nest the action stuff. This was very essential for the work in SolidStart. So I just wanted to kind of point out this is super powered because this is like the kind of use case that I feel that's been missing for people. Because like, what if the data does come from an outside source and you don't get to do fine-grained updates? Well, now you do. All right. No comments on this one. I thought this one, like in my mind, this is the one that people would be most excited about. But maybe apps aren't there yet. The last thing I want to talk about on resources is something called this one is probably not going to matter to most people on the stream, but unless you're someone working on Astro or Fastify. Actually, sorry, one question did come in. Is something like solid query bound to create resource? I think this is something to discount. It should be. The thing is, we don't just throw promises, which is a difference from React. So the resource is that async primitive. So no, like, people have been talking about stuff like, I haven't looked at solid query yet and seen all that, but like what we want out of these kind of integrations is just a caching system. Solid already optimally handles all the mechanics around refetching and suspense and all that kind of stuff. It's kind of, unfortunately, on the React side, it's like the opposite, where like when Tanner had to go and add the suspense stuff, he had to actually like go and add the suspense stuff and like figure out how to handle it, and you have to toggle it with a flag. With Solid, you just use create resource primitive and it's all built in. It just works. You know, transition, suspense, all that stuff. But it means that universal solutions, maybe the boundaries are different. Like really, we just need the caching mechanism, and you can always abstract the caching through using the resource fetcher. There's been multiple libraries that do that. Maybe none of them are as featured as solid query or TanStack query is, but like if you can see how you get there, because if you get to use these primitives that are baseline in Solid anyway, it's the same thing used in our router, the same like primitives, those libraries get small. Like there's no reason for a query like add-on on top of Solid's resources to be more than like 5K. And I mean even with all the features of like TanStack router or sorry TanStack query, like it's just like all the pieces you need, all those just are built in. So I think that's one place where the agnostic solutions are gonna there's a shift because of this primitive, but we need the primitive, as I mentioned, because it's not just a promise. We don't throw a promise and throw away your stack. Our suspense resumes fine-grained. Yeah, this works perfectly fine if we can, because you get to write the setter. If I can pull up this code again, the only problem is you're going to have to figure out how to make TypeScript not complain, because I don't know how to yet, but people tell me it's possible. Because look, you write the setter, so if your setter, you could do something like if you need deep updates, like you can write whatever setter you want. The thing is, you just have to recognize that if it's coming from the create resource itself, it's just going to pass you the data. So you might have to do a little bit fancy, but you can anchor stuff off here. Like you have, this is what gets passed right back out through mutate again. So you have complete control here. Is a minimal caching thing outside the scope solid? Yeah. But it's super easy. Have I showed this on stream? You could literally make a simple caching thing by just like going outside the resource and going like const some object and put a key and then using the fetcher. Like, I probably haven't actually showed this on stream. Maybe that's worth doing it at a different time. But like, the problem is it's so hard to make assumptions about caching. Like there's a billion different ways to do it. And I tried stuff like coming up with cache components and all this stuff, and it was a mess. And I realized at every point, even if I came up with a custom cache thing, the custom cache thing would have to have a way to inject a custom cache into it. It just, and then I was like, well, what's the value here? Because it's hierarchical. Well, sometimes caches aren't hierarchical. There basically was no, I spent a long time on this I'm trying to remember what release it was, but like I spent over 6 months toiling on this and writing in Discord about that. Right. So like, yeah, I mean, if you think about it, it's just because as I said, these mechanisms are really, because there's a fetcher in create resource, you can always intercept the query coming in and then be like, oh, don't run the request, just fetch it, just grab it out of a cache. So you have completely the ability to then, once you write this custom caching logic, to wrap your own create blank resource and be able to use it caching. And SolidStart doesn't do much with the caching, but it does use key invalidation similar to React queries. So it's just an example of this kind of being used. Because these are all just options and things you can pass in, it's very composable. As I said, I couldn't make, create resource is kind of complicated, but in my mind right now, it's as simple as I can possibly make it. And I know there's a lot of stuff on here, like why did I add all these states if it's as simple as I can make it? But like the real attempt here is to make this as basic as possible. It's just part of that is slicing up the responsibilities and understanding what pieces you need, right? All right. Sorry, not this one. So that's it for resources. There isn't actually. Oh no, that isn't. Sorry, I didn't get to do the last one. I got interrupted. Which is good. Just double checking. Anyone else have any more questions about stores and whatnot in create resource? Just take a drink here. The funny thing is, what I love about some of these changes is, and this is why I'm emphasizing so much on the decision-making process here, is because a lot of thought went into these and like a lot of conversation. But the implementation for some of these things is really simple. Like, look at this, option.storage or create signal. Like, to implement this was literally passing an option through and just like, there, implemented. Like, this is, this is very easy, because then this is the same stuff as before, set value, which then gets passed in out as mutate later. Like this, I did try and keep things as simple as possible, and a lot of these things actually weren't hard things to do. They were just things that required a lot of thought in terms of API design and where this goes. Okay, so the last thing on the resources is something that probably won't apply to most of you. Mostly interesting, probably people who write like Fastify DX or like islands frameworks around Solid, is sometimes you want Solid. Sometimes you want Solid to more or less how should I put it? You want Solid to have resources and do all this stuff when it wakes up in the client. You want to be able to do client-side routing and transitions and all the nice stuff. But when you initially render the page, probably from a server rendered page, you don't actually want Solid to fetch the data. Like maybe it's islands, maybe it's coming in through props, maybe you have some serialized data that you do in your framework to do data fetching, and you don't want Solid to handle the data fetching. See, what's wonderful about Solid solution is, if you embrace it completely, like SolidStart or Rigidity or whatever, the resources just do all the work for you. Like you just create the resource. It does the fetching on the server, auto serializes the data across the line, and then wakes up, hydration's like, oh, okay, there's the data source, and it does everything, and then it updates on change, and you don't have to do anything. It just magically, automatically works. This is the other reason why we have resources, is because it just connects the server to you don't have to worry about double fetching, you don't have to worry about serialization, everything automatically works. But if you have a solution where it's in your benefit to do the fetching out front, like these ones, like Solid has parallelized data fetching and nested routing, so we generally don't need it for our own solutions. But let's say you're Fastify and you want to build your own framework around Solid and you want to do the data fetching, or you're Astro and it makes sense to do the fetching outside the islands. Sometimes you not only don't want to fetch on the server and you don't want to fetch on the client, you just want a way of injecting the data and going like, it's good. And the thing is, resources already have something called initial value. But initial value is more just a placeholder, like what if you never fetched? Or, and what if, or you want something in place before you fetch. And what we want is something that say, hey, actually don't do the fetching. And there's ways to do that already. You can already set, we took the same convention as SWR, whereas if your source, like your query, is null or undefined, we just don't fetch. But it's really awkward to have the server not fetch and then the client not fetch. And you're like, well, no, actually, where's the data coming from? Like there's this weird, because the second you want the source to actually be subscribed to something, you want to go like on this parameter change update. So people have been doing weird hacky stuff where they like do an is server check and then they create a signal on the server and then they create a resource in the client and they like set it false and like add all these conditions. I was just like, oh man, this is nasty. So what we do now is we can say when you set up your resource, you can just go like, tell me where I initially want to load that data from. Is it from a fetch on the server or is it from this initial value blob? And because it's part of the SSR process, it's not going to refetch on the client regardless. But this will tell the server like, hey, don't serialize the data. It's already in this initial value, which will also be in the client code, obviously. So you have the ability now that the resource data gets serialized however you want. Maybe you put on this .data thing. And then in the client, when it wakes up, it goes, okay, yeah, I'm going to fetch it from there. But it still runs the source, the reactive part of it, so that it creates the subscription. It just doesn't do the fetch. And then when the next time that subscription changes, well, then it updates. And this gets rid of like a whole bunch of custom code these people were writing, and they can literally just go initial SSR load from initial value. And yeah, this is, I said, mostly for those kind of framework writers, but this is just, it takes away a whole nastiness. Is this discussion all reflected? It should be merged imminently. I created a PR. I imagine it's just getting reviewed and it'll be in the docs now. The cool thing about this release, as I already mentioned, is there are some behavior changes and like a couple small things, but it's about the direction more than anything. But yeah, for now, use the release docs as docs, but these will be merged very soon. Right. So that's it for resources. Let's talk about SSR. Okay. Gonna make a quick banner here for myself. I spent a lot of time on SSR in this release. A lot of time. And it's been this continuing cycle. I don't know if everyone probably knows or wants to know the history here, but when I first created Solid, I didn't care a bit about SSR. Solid's client-side rendering is really fast. In fact, it's a funny story. I was doing a benchmark with the builder guys, and we were all like sitting there, and I was trying to figure out, I'm like, why is hydration so slow in Solid, but the rendering so fast and all this? And actually the answer to the question was Solid was server rendering and then completely re-client rendering in this benchmark. And the funniest thing about it was it wasn't even the slowest. It was still like faster than most of the frameworks doing twice the work. But again, I was doing a lot of this benchmarking, and that was kind of part of this was because this kind of picked up the conversation with Builder, and I finally got to do a bunch of work I wanted to do in a long time. And what this comes from is, okay, at the beginning, Solid, sorry, kind of step back. In the beginning, with Solid, we didn't do SSR. And then the first version of SSR was really quite bad. We put the DOM and reactivity yeah, I don't know if sometimes it's easier to maybe just write this out, okay? So version 1, and actually let's get this here, just so you can see this kind of progression. I don't know if this is value for anyone, but we had the DOM plus reactivity on the server, which don't ever do this. So we had like JS DOM plus like client version of Solid, right? And the reason I wanted to do this was because I had no idea how I could possibly update things after the fact and stitch it all together. So the first thing I did was I was like, okay, let's get rid of the DOM and do a string concat. This is probably like too lengthy. So now we just have the client version, and it could do all of this stuff. And this version was okay, but honestly, reactivity on the server put us into like really slow, like on benchmarks and stuff. We were like as slow as like React or Preact or something, right? And I was like, I guess, oh, fine. Like, but we were no Marco, we were no Inferno, we were no Svelte or Vue even. Like, we weren't in a good place here. And I was like, okay, well, what can we do differently? Well, and when I did my research, what I realized was we didn't need reactivity for synchronous rendering. So like, there's a couple different methods. Like there's like render to string, right? Which just runs synchronously. And then I created render to string async. And this is why I needed the reactivity, because if like some data fetching happened and then it loaded, I needed to be able to update stuff, right? So this is where render to string async came in, right? And to be clear, at this point, we already had suspense on the server and stuff. This is like 3 years ago, but like the mechanism was still kind of similar to what we have now. But it was using all this reactivity. And but it was really slow. So what I ended up doing, I was like, okay, I realized when I joined the Marco team in 2020 that I wanted render to stream, okay? And the problem was like, I could do a third version here, which was string concat plus faux, like plus like mock functions. What I mean by that is I could concatenate strings instead of like using a DOM, and then instead of using signals, I could literally just return like a function that returned a value, like just fake reactivity. And like, you can tell that each one of these is like slowest, slow, faster. And when I did this and did a bunch of optimization, I wrote that article a couple years ago. Solid was the, where was it? Like medium. Sorry, not, maybe it's easier to go. How I wrote the fastest JavaScript framework. There we go, again, yes. Yeah, you just search that on Google, you'll find all my old articles. And this synchronous approach, anyways, and we're working with this, is eventually what led to the kind of huge performance gains that we had. Still hold true to this day. But the problem was it didn't work with render to string async. Right? So let's see if there's garbage in the chat. Let me change that. Okay. So essentially, I was like, I was like, oh man, this sucks. I could do this work, but okay. So it's like optimal, poor, and then when I looked at render to stream, I realized something. Originally, I was like, because I was like, oh, this is gonna be poor, right? But what I realized was, if I only streamed the data, but didn't but only like if I rendered the shell synchronously, the same as rendered a string, but then only streamed the data, so nothing like re-rendered or did like updated on the server, I could actually, and this was the revelation around that time, use option 3 to have super fast streaming and then sync the data over and then have the client render the data after the fact. Now, this isn't pure streaming, but it allowed me to basically have 2 modes of SSR and 2 different compilations actually originally. So essentially, if you wanted render to string async, you got the poor version. Otherwise, you could do the optimal version. And you might be asking, why the hell would you bother with having this poor version? Well, the reason is SSG. Because I didn't want a browser to do SSG. I needed the whole thing to resolve. So SSG could be slow. And then I was telling everyone else, use render to string or render to stream. So this is like a really simple way of doing it. It's different than what we do today, but essentially, you could basically do that first render where you render the page and render the header and maybe the sidebar, and then essentially could have like sections. No, this is black still. Sorry. Could have like sections here where like, oh, the content, like obviously the main content needs to be loaded in after, right? But maybe even the contents of the sidebar could be loaded in after. And what we would do is we'd client render them. Yeah, sorry, SSG is static site generation, right? But my point is, what we do is we'd render this black shell, and then after the client, instead of doing, and we'd hydrate it, and then when we hit these boundaries, which happen to be suspense boundaries, we would just always client render the suspense boundaries. So replace the fallback with client rendering. And this was actually like pretty performant, pretty easy to do. And it meant that I was pretty happy that we basically had the fastest SSR solution because I could make this assumption. But this is a terrible place to be because we had like 6 different compilation modes and like different versions, and it was not fun. So over time, and this is a really long explanation, obviously, to get to where I'm getting at, I started merging them with every release, kind of getting them closer. The first thing, and finally, I think around when I want to say around 1.0, I managed to get rid of reactivity on the server. Like I got the base first. I was able to get rid of reactivity on the server, and then I was able to merge have them running on like the same compilation, and then finally around 1.3 when I did the new streaming, they actually share most of the same code, except there was specific hooks like in the code, like if you're async, do this, if you're stream, do this. So there was like specific code paths. I almost had like 2 versions of everything on the hydration and the server. It didn't affect hydration that much. For 1.3, I managed, the big thing that I did with 1.3 was merge the hydration logic. So the client could hydrate the same whether it was async or streaming, but the server still had different paths. With 1.5, I finally merged this into the same thing completely. And I mean completely. Like if we go to DOM expressions now, and you look at the implementation of the server render to string here, or sorry, render string async, it's literally calling render to stream, and there's a promise. It's like render to stream then. And I actually, the way I implemented this was use the same render to stream code and then added a then. Right now there's like a pipe, and a pipe 2, which is how we like do the difference between node streams and readable streams. But what this, I mean, even though I still ship the separate APIs, what we're moving towards here is actually having a single render function on the server, more or less. Basically, an async render is just a stream that flushes at the end. And this is no revelation. That's how React works too, like with their streaming renderer. But it took us a long time to get to this point. And the benefits there, well, it's not the benefits. The reason how should I phrase this? The reason I wanted to go here is because these worlds kept on colliding. Because in a let's get back to my scala draw. In a streaming version of something, you can always know that the shell is going to have streamed at the beginning. So like when you do like an error boundary, if something throws an error later, you just throw it across the network and the client renders the error boundary. And similarly, like when you have suspense, you render the client, and then as the parts come in, you ship the HTML and you insert them, right? And that's like with 1.3 we had the full HTML streaming, and that just kind of worked. But with async, you do all those insertions on the server. So I had like slightly different code paths because I was like, okay, we need to do a string insert rather than flush a script that makes the browser do it. And the same thing with error boundaries. And while these things were separate, it was a lot of extra kind of code to manage. I knew I wanted to put them together, but I was forced to it because we added a feature called defer stream. I understand. We added a feature called defer stream, and I've talked about this before. And what defer stream does is it lets you like selectively choose when to do that first flush. So like you could be like, oh, I actually need this sidebar content before I flush the stream. And again, I'm not getting into too much detail. We've done this on a different stream, but essentially you could select like on the resource, go wait for this one. And in that case, you actually do want to do this insert on the server instead of in the client. And while I optimized some of those cases, for the most part, I did what I always did. Async was the one that took the hit. So essentially, if like error boundaries always rendered on the client, even if they could render on the server, simply because it's way simpler because I had that logic. And now that those lines had blurred because of this whole like defer stream thing, I knew I needed to come up with a different approach. So this is what motivated that. I booted this person twice. They're like different people. Yeah, and I'm the only person who can do it apparently. Anyway, I guess like if I had mods in YouTube or something, I just don't know enough about that. Anyways, what I'm getting at is these lines very quickly blur, and with 1.5, we actually now, if you defer a stream, we'll do the work on the server always, because that's the same as the work we do if it was async. And if it's streaming, it's working the way that it has since 1.3. And what this means is ultimately we've taken what started as like two completely separate systems, separate compilations, separate runtimes, and now have finally merged them into the same routine, the same everything. And it's just a spectrum, which is really cool because as I said, it made me focus on adding more features and being able to improve stuff. Like now that we have those guarantees around server rendering, we added on cleanup on the server, which you might think is weird, but we do render effects on the server, like things that to do rendering. So you might need to do a cleanup. Like if you hit a branch, this came up in SolidStart. What if you set a status code on one branch and then it fails and it goes to the error boundary? Well, then you might want to like unset the status code or the header or the whatever, right? Like, like the meta tags. Because we build this all into the way Solid renders, being able to use the same mechanisms to clean up makes a lot of sense. but yeah, I spent a whole bunch of time benchmarking. I managed to improve the raw string rendering by about 8%. And I want to give a quick shout out here. A lot of libraries, serialization is a big cost and a big thing. A lot of libraries use a library by Rich Harris called dvalue. I don't know if you've ever seen this one, dvalue. I think even Vue uses it. Dvalue, Rich Harris. It's very easy to use, and it lets you serialize stuff across the wire. You can basically just go devalue this object, and then inside your script tag, you can literally just like read it in and server render it. What I ended up doing was get a little Marco magic in here. Dylan from Marco had written his own serializer a couple years ago, anticipating Marco 6, and they're still working on it. Their serializer for actual Marco 6 is crazy because of like all the resumable stuff. But he gave me access to his repo where he wrote his serializer, and I mean, we benchmarked it. It's like 6 times faster than dvalue. So even in simple benchmarks I was doing, I was like seeing like 2-3 times improvements on the overall server rendering speed. So I am pretty stoked to have access to this hot piece of Marco technology. I gave him credit and whatnot and link back, but he might want to release it at some point so I can give him proper MIT credit and stuff. Oh, I'm guarding him on MIT. No, seriously, I didn't cover this, but I was doing benchmarking, and yeah, I don't know if this is the right time to talk about it. Yeah, it probably is. You all might have seen, what was I going to say? You might have seen that tweet that I talked about from last week. No, this one. The benchmark one where I was showing the numbers from Builder or whatever. This one. And I'm just going to talk about this for a moment. This one was a raw rendering one, so it was fine, and Solid has a good score in it. It's very simple. It's like a hello world, so like this doesn't show very much. Solid has a very fast renderer, but Steve backed up a bit and took a more advanced example, and he freaking auto-cannoned it. And what was noticeable is like Solid was still like top 4-ish or whatever in Svelte, and we were kind of all in this kind of same range. Like everybody was like at like the throughput on them was at I'm trying to remember what the numbers were, but like I don't remember the scale, but let's pretend everyone was like 9, like 10, like I think Svelte and Solid were around 12. I think Fresh actually beat us around 9. Quick wasn't in it because they had a bug or something apparently. But you know, and all the way up to like things like Angular or Next, who were about like 16 or 18 or something, right? Marco was 1. Like everybody was like in this range from the 10s to the teens, and Marco was 1. Like it was just insanely faster. And I started looking into it, and there's just so many details that you don't realize. Like Solid might have the fastest string renderer, like the actual rendering is the fastest, and you're not going to get penalized too hard for how you string render in JavaScript. But like I started like the length of the HTML actually started making more impact on compression. So like how much you serialized, or the all the overhead. In our case, we're using SolidStart, and actually converting to the response request objects that we're doing, where Marco was just using like Node directly, had an overhead. That's another thing. And like almost the meta frameworks have a bunch of unseen overheads that are probably more impactful than the rendering that you do with them. Like I know from benchmarks how fast Solid renders, but whether SolidStart still does decently, but like it's only one piece of the puzzle. And I think we haven't done enough good benchmarking on seeing the whole overhead of the meta frameworks, because in a lot of cases the bigger meta frameworks have like that overhead makes way more of a difference than like how slow React is. Anyway, just I spend a lot of time in here because one of the benchmarks, I couldn't get the number down in Solid, and I tried all this stuff, and I changed the asset insertion and like a whole bunch of things. But we got a bunch of performance improvements out of this. They're all measurable, so I'm like happy about that. But ultimately, like inkling out throughput numbers when put into like a real world situation. So I think it's interesting. I said I'm proud of where SolidStart is, given how new it is and whatnot. We score pretty well on those benchmarks, but like you look at something like Marco and you're like almost embarrassed. You're like, whew, like it's just so much faster. So just sorry, a little tangent, but just kind of talking about the benchmark, because you're only as slow as the next bottleneck. We're going to do more work here in SolidStart in the beginning or coming up as we gear up. Right now, it's pretty safe to say when you step out holistically from it, actually SolidStart and SvelteKit are they're neck and neck on performance. They're almost identical. So even though some of the benchmarks would suggest that Solid is much faster than Svelte, when it comes down to actual like kind of holistic benchmarks, I think today we're very, very similar. Kind of coming out at slightly ahead of Remix and Next and Nuxt and Angular, Universal, and all those solutions. So yeah, still places to work on. We've optimized some areas, but there's more work to do. Anyway, but yeah, that's the thing. Like I did some good work that improved some benchmarks, but we still need to really engage the whole holistic view of performance on server rendering, and that's why I'm very glad by the work that Steve and Builder are doing there. All right, sweet. I think that's it on SSR. The cool thing about SSR is you don't have to do anything; it's just faster. that's the key part here. I think we actually talked about most of the things. There's just like a lot of like low-hanging fruit stuff like CSS types now in our types, which improved our JSX types slightly. I fixed a bunch of bugs. Fixed that scheduling benchmark someone had made. Someone had a benchmark that showed React was faster at like concurrent rendering. I fixed it so it works in Solid. That's most of 1.5 release. To be fair, it's, as I said, it's a bunch of little things. It took a lot of work and a lot of decisions in the process, but it just makes the whole overall package just feel a little nicer. Less places where you're going to get caught up or stuck. Well, I hope at least. I still occasionally I watch streams when people pick up Solid for the first time and don't really look at the docs, and then they have a really hard time. And I still reflect on that a lot, trying to figure out how do we make things easier, like because that's the last thing anyone wants, So yeah, I hope that we can avoid that more in the future. There's like definitely a balance between giving people the right level of control and power to make performant apps and making it intuitive to people coming from all different sorts of backgrounds. You guys are killing me. Yeah, well, but not only him. I watched a Cassidy stream that was like that too. But yeah, that was the one that was most recently. Yeah, and a lot of great stuff's been happening, especially since the Astro release. You know what? Let's shift gears. I think unless there's more questions about 1.5, I think it's time to get into This Week in JavaScript. Let's get ourselves all ready for that. It's funny though, because I actually don't think This Week in JavaScript has a ton to do on my on my thread. Let me just pull out my notes. Give me a second. Everyone still doing good? My batching explanation didn't cause your brain to melt? You still here with me on a Friday afternoon? Or whatever time it is where you are? All right, yeah, okay. Let's clean up a bunch of stuff. No, that's not what I wanted. Okay, give me 2 seconds here. All right. I could do this all off screen, but that would ruin half the fun, right? Sweet. It's funny. This week in JavaScript, for my personal stuff, wasn't actually a ton of things until like the last couple days when everything kind of started blowing up. But on the other side, there's been a lot of other conversations that I see are probably worth talking about. Let's start that one there. Okay, cool. And there. Okay, I'm all set. So let's get ready here. Yeah, not the afternoon for you. You're a trooper. That's all I gotta say. Yeah, thanks for that. I'm going to start clipping This Week in JavaScript separately. If you notice, I've been doing that recently, how I've been approaching it. So yeah, we're going to be making these pieces more accessible in the future. That's my hope. I don't think my content really lends to being like clipped 8 billion ways. If you ever watch Theo stream, he literally just like, he's just like, okay, let's get ourselves situated, and he's like on for like 10-15 minutes, gets the perfect clip, then he's like, okay, what's next, guys? And he lays out his stream like in these segments, and then they just make the perfect YouTube videos. I don't think I'm ever gonna be on that kind of thing. All the stuff gets too tied together and in depth, but we can pull out This Week in JavaScript, so that's something I want to do. All right, so let's get that ready. All right, it's time to talk about This Week in JavaScript. For me, I have to admit, I was kind of detached from a lot of the other conversations that have been going on. I've been thinking a lot about the future of Solid, right? Solid 1.5 we were gearing up to, which was the theme of the stream today. And I can't think about the future without thinking about the problem of hydration and resumability. And I kept on seeing these discussions where people were talking about resumability and like equivalating it with like what Quick does. And I felt that wasn't a really accurate view of it. So I wrote an article, and the funny thing is I had a lot of fun with this one because it's a tough technical problem, but the whole situation is kind of absurd. So I hope that came across on this article. Google apparently didn't like it. This article did not get picked up by Google search or like Android search, which is usually like my bread and butter. Maybe they just didn't appreciate the title and stuff. But what I mean by the situation so absurd is that things like hydration, in a sense, have no business existing, and resumability as the solve for that sort of is in the same boat. And these are also the terms that no one really gets. Like, I'm sure Mark Deglash knows what hydration is, but it's still a funny joke because, let's face it, like, hydration makes you think about water. And I mean, there's so many levels on this one. But essentially, you can read the article, get more details. But I'm very excited by the work that Mishko and all the guys over at Builder are doing in terms of resumability with Quick, and also the work being done with Marco 6, which is also along that same path. And I thought it would be worth trying to yet again try and kind of generalize this, because I guess I have a slightly different opinion than what's been telegraphed so far on this thing. I think there are things about Quick and Quick's architecture that make it very impossible or very difficult to impossible for other frameworks to replicate. There's a reason why Quick is the way that it is. And there's a reason those other frameworks are the way they are, and they split. However, I'm not convinced that resumability, the actual core resumability part, couldn't be applied to other frameworks, which is is why I'm spending so much time generalizing it. Because I've watched Quick take it one way and Marco take it like a completely different way, and see that there's a huge amount of similarities, but where the common ground is enough of an overlap that it should be possible if your framework meets a few criteria. And that's something that I'm going to probably establish more in the future and write more about. But I just wanted to start establishing the baseline here and the thinking so people can understand exactly what resumability means. That's why this is important, because the work here is important, because we do want to get away from hydration. And the key there is getting rid of the runtime components, which if anyone's been following me in Solid know that that is what Solid does. Solid is not resumable. But the key part to make something resumable is being able to break something that looks like this apart into something that looks like this. And that is, I mentioned earlier about promises and reactivity. That's definitely something you can do with reactivity. You just need to be able to serialize it. So yes, this has been on my focus. And the thing is, I think there's multiple ways to approach this. Right? What I'm about to draw right now, actually, I'm going to slide down just so I can keep it. It might not make sense to a lot of people, but I want to show you a sort of path that probably I've been thinking about, because this is probably not the path that you think about, but if I'm there's a certain common mindset here in terms of approach, and it's not about where you fall in this list, but it's about understanding the shared heritage here. And this is an idea that I'm just kind of playing with, but I wanted to kind of throw out here for you all, because it might give some indicator. Here, yeah, I didn't forget view. View's just not on the same side. And this, people are probably going to be like offended by this, because people are offended by every chart. But this is not a philosophy chart like I usually do, or values chart. This is about an implementation chart, and why I'm not convinced that not all frameworks can not do resumability eventually, if you follow this. The funniest thing is, between each generation, the people look at the other side to get influence on the solution. I like, this is just kind of something I've been working with here. But what's common about this side, the top side here, is that it's like this top-down thing. And to be fair, Quick isn't a perfect representation of an extension of Solid. It's just the best that we can have. But this is like the difference between the fine-grained and like event-based, and the difference between the like top-down compiler-centric approach. And to be fair, React is not a compiler, but you have to understand that. And when we get over here, the lines blend enough that I don't know if this is exactly true. But what I'm trying to get at is, in Angular, you had this like digest cycle where like you made everything dirty and you re-rendered, essentially. It could be Backbone, you could put whatever. React added a VDOM that improved on it, and it kind of borrowed from the MVM model from Knockout, essentially, of like components, like the idea of making instance-based stuff, where Angular had like ng scope, it didn't account for it. Vue came from the Knockout school, but it borrowed from Angular a lot of the stuff it did for binding and whatnot, right? Like in terms of like how syntax and what it represented. To be fair, it added a VDOM also from React, so like you can see that it's kind of coming from that side. Svelte took that simplicity from Vue, but kept a component-based system where, like, essentially components are what we render. Like it's not like reactive in like the more common it's not reactive in the way that like reactive systems are reactive. And then Solid borrowed from React on top of Vue side to take the philosophy, but what it did when it went from here to here is it actually further granularized the rendering, right? So like there's this like API cross matching while the technology of this is going here. And yeah, I mean, maybe this end part isn't exactly correct because technically Marco is more fine-grained than Quick, but Marco is using a compiler to basically run, like this part is arguable, okay? But what I wanted to get at is the way the hoisting, like it's actually possible that I actually have these switched. It's actually possible that Marco belongs here and Quick belongs here. These are closer, but that's kind of the point. We're hitting a potential convergence point here, and what I'm trying to get at is when I look at Svelte's compiler and how it influenced how Marco does resumability, and I look at how Quick serializes reactivity that's similar to Solid, right? It's not quite as fleshed out. They still have a VDOM. You kind of see that, like the reason I have this line here is React Forget basically could make React into Svelte, right? Like it's essentially memoizing at all the decision points. And Vue Vapor could make Vue into Solid, right? So how far do we have to go to make Solid into Quick or Svelte into Marco? And I'm going to argue maybe not that far, right? I mean, there is a question here, and that's sort of what I'm looking at here, because it's harder to do the whole mile. Like, it's very hard to picture React becoming Quick. Like it might not be because they can't do that, but maybe that, Michiko is very vocal about his generations. Maybe there's already been a generational architectural middle ground that's already happened that we just didn't acknowledge, so to speak. And it's because these have to leapfrog to that it's harder to picture, right? So like it is like when I look at this, when I look at Quick and I look at Svelte, they seem the closest to being able to do resumability similar to Marco or Quick, right? But when I look at what React and Vue are doing, they're looking at how they can become Svelte and Solid. Like, and at the point that Vue becomes Solid, can it also become Quick? Like, yeah, I mean, to be fair, these two are so experimental that I don't feel like we've seen their final version. I want to see Quick get more fine-grained with this reactivity, and I want to see Marco's solution is actually amazing. I just want to see it actually, I want to see it actually come out, right? This is the question you should be asking, right? Because what do these have in common? This has been what I've been struggling with since January. And this is what I talked about in the Future Solid stream. Is are we inevitably forced into heavy compilation? Because that's a place that I don't necessarily want to go. But to be fair, the compilation might not be that heavy depending on what the patterns fit. Because like Marco, very heavy. Like Svelte level, like more than Svelte. Because Marco cross-file and analyzes everything and knows the whole universe, and it's going to be pretty hard for any framework to come even close to it from a performance optimization standpoint. especially with marketplace. It's just so far like down that path. It's insane. But the question is, how composable can we get this stuff? And Quick already has, with their $sign, has already suggested that there's a path there. But I mean, I think it goes beyond that, because thinking even further in terms of primitives and what that means. Like, even with the server function SolidStart, I have this feeling of these kind of pieces. I feel like there might be a place where the compilation can still be reasonable. Yes, exactly. And that's what I mean by React becoming svelte. Right? Like it's in this view of the world, they're just further behind on this curve. Right? I don't know if everyone can like go down this path and it makes sense for them, but well, it's not a matter of, I don't think so. It's resumability is a hydration technique. So if partial hydration could be deferred to SolidStart, and like the whole lazy loading bit, like SolidStart. I've had conversations where using solid in quick could maybe be like the holy grail of that thing. Have solids fine grained with quick's ability to slice some stuff up. I think there's still like questions of how big those chunks are. I'm not completely sold, as I mentioned multiple times, on how big those lazy loaded chunks should be. Right? But I think it's, I think there's still details to work out on the quick side on that. But generally speaking, resumability is just a hydration technique. So if we can come up with a compilation that lets us do better hydration and better SSR, I think that's something within our wheelhouse. Orchestrating it, islands, what lazy loads, all that stuff, that definitely can be separate. But for me, resumability, and why I'm so focused on it, is actually a core concern. Well, Astro is, like we were just talking about, one of the orchestrators. Like, Astro is not on this chart because Astro doesn't worry about any of this, right? Astro will be like, oh, you want to do this interactive thing, you can use jQuery or you can use Solid. Like, Astro doesn't care. They're working on patterns to improve the orchestration, like the routing and the islands and stuff. The way I see Astro in this picture, and why I'm so stoked on people using Astro and with Solid and doing that stuff, is like Astro makes it really nice to build certain types of sites and content sites, and even go beyond that. Astro can get pretty complicated. There's an example that I want to probably show on the stream in a minute, but like, this is, resumability is a core framework concern. So if Solid becomes resumable, then Astro with Solid becomes resumable. Do you follow me? So this is just where all this thinking goes, because you can have resumable islands. Like, resumability is independent of how you slice up the code. And I don't think, that's why I wrote the article, I don't think that is understood by most people when they read something, because it's of no fault. Just Quick is an amazing solution that takes all the considerations into play and builds the whole thing. And I think that's amazing. But, it's funny because I'm not a framework agnostic kind of guy, but I am definitely like a lessons learned generalist, because I like weaving the threading the needle. I like finding the path that lets me navigate things in a slightly more optimal way. And from that perspective where I'm sitting, I'm very curious on what things are rules and which things can be bent. So yeah, I think Astro and Solid have a long future of being best buds, so to speak, because as we improve these core mechanisms and Astro works on their ability to orchestrate it to make the best possible content sites and those kind of like that area where they focus on, you're going to have the best combination there. SolidStart might be able to do the same stuff as Astro, but as I said in the previous stream, like, even if we were like technically more performant or whatever, it's not going to attract the same kind of thing. Like, we're focusing on a different sort of experience. And I think even as things converge, the experience is going to be important. Yay, Astro. Yeah, a lot of Astro love here. So that's the thing. The challenge on that side is that do the lines between the meta framework and the like core framework blur when you have to do anything. The thing that Quick and Marco have in common is they realize they're like, crap, if we're going to do this, no one else is doing this. Like Astro isn't bundling the way we need to bundle. And like, if you're going to do this, you end up putting all the work in to build the whole infrastructure from end to end because it didn't exist for you at the time. And depending on your approach, you can get you can get in there. Like people asked, or I saw a thread where someone was like, oh, so Quick plus Astro. And kind of, but you wouldn't get the best out of, like, it just doesn't make sense. You wouldn't necessarily get the best out of Quick. Like you could do that in a sense, and maybe someone will. And in a sense, Quick's core experience is more, feels more like something like SolidStart. So maybe like Astro from a content side would like give that experience thing. But like Quick is already completely decided that it's going to handle that part of the puzzle, and it's still working hard on that side. Containers, micro front ends, like they're doing more work there. Like they're going to just deliver their solution. Marco is a little bit more interesting because now as other frameworks have abilities to bundle stuff in ways that are Marco compatible, I could see them more likely to slide into them. But again, the thing with Marco is like the primary use case or like experience is similar enough to Astro that's probably why they want to integrate, because they're like both like, I'm HTML first, you know. So yeah, there's more nuance and complexity when talking about how these different frameworks come in, but all the ones that I put on here are your typical client-side single-page apps, and I think there's a path forward. That's all I'm saying. Yes, can you please show a real-world example for resumability? Well, and this is the thing that why I suggest like reading the article. It's resumability is good in theory is good in any case, because all it means is we don't hydrate. So when the page loads, JavaScript doesn't run, and then when you interact with it, some stuff runs. But it has nothing to do with lazy loading. So a real world example for resumability is literally anything. That's the problem. It's just like it solves hydration if it successfully does it. I think we need to measure and understand the trade-offs in serialization. But in theory, there is no use case for resumability. It's just better, period. Which is a weird statement to say. Can presumably have slow networks. Oh, yeah. Because what everyone sees is what I was talking about, that lazy loading thing. I've done this like so many times on stream where people are, I pull up the Quick Hacker News example, right? And I go to look at a story, and then I go here, and then I go, oh, look, slow 3G. And then I click the button, and then you're like, oh, there we go. But the reality of it is you're going to preload that in the background, and resumability has nothing to do with this. That's what I was trying to say. If you read the article, this lazy loading thing is something that Quick does, and you can always preload, but you could also just have all this JavaScript to begin with, and it work instantly. Resumability is about not executing code. It has nothing to do with loading code. I want to make that very clear. This is what people associate with resumability, this lazy loading. This is not resumability. I think this is, I've been trying to shift the message there, and I think Michko has been recently as well because of this backlash. Quick does multiple things that are not resumability. Yes. It may never be optimal solution for everything, but will be a great place for other servers to converge and some things. Yeah, it's a great platform for experimentation, to try different things. And honestly, for its baseline case, it is just so great. That's why you keep on seeing people using Astro, because they're just like, wow, I just grabbed a website and I just dumped it in and it just worked, and I'm happy, because for a lot of things, that's all you need. Yeah, if you watch the stream, we do support stuff like islands and client-side navigation with islands. So It's experimental, but yes, SolidStart in theory technically could do the same stuff. But I think you're underselling Astro if that's the only thing you're looking at. Yeah, yeah. It's also a very easy thing to kind of put out there. I agree completely. Like people are just kind of looking at me like, oh yeah, like this is an easy point to make. But the unfortunate thing, and you're going to see this as benchmarks and stuff come out. Not for Astro is really good for its use case, so not for that. But for like SvelteKit is really quite good. SolidStart is going to be really quite good, and I hope that people give it a chance. But Astro is an easier sell. But like again, that's because of the migration story. Because maybe you start with your Next.js app, you move to Astro, and you maybe switch to Preact at that time, and you're in a pretty good place. Or maybe you switch to Solid. Like it's a really nice story that just works really well for a lot of things. StreamYard does this automatically. I need to, if I'm not careful, I tell it to use my last category and it just keeps on switching it on me. Well, yeah, I mean, like, this is why I'm saying that resumability getting conflated is really where my concern is. And the reason I wrote the article, because quick is resumable, period. You can use the optimizer to decide how it bundles. So you could just say like load all the JavaScript up front and it just won't execute it. And I think, funnily enough, for most of the type of sites where people are making like the head-to-head comparison with Astro or whatever, that's what they should be doing. Like it really, that lazy loading thing is kind of a cheap parlor trick. But this is my own personal feeling. I think with a really like expensive, complicated app, like the thing is, Quick can scale all the way into SPA mode, like full SPA feeling stuff. If you're going to go there, yeah, you want to be able to slice stuff up like this. I think for most people, if they could just be like client load, or whatever, like the way that they mark the islands, that's all they need. Like that handles like the 90% case, like the Astro thing. I think but resumability, the actual hydration story, that's important. That makes a difference, and that's why I want to like draw or separate those lines. Yeah, right. And once you understand that that's the mechanism, you don't. It's not about what I just showed everyone with the whole like lazy loading thing. It's literally just boot up where you left off. The funny thing is, sometimes with those demos, they kind of get a little overstated because like any SSR page, if you copy the HTML, boots up like that. I mean, like because there's a script tag that starts the process, which means if you copy and paste it, like it works. I think the challenge with some of these demos is like there's elements of this that literally happen. Like we need better demos to differentiate the elements of it, because you can go, yeah, sure, I can copy this HTML and have it boot up. Like I think because like the script tags in the JavaScript are present. So I think the difference also is Quick is you don't run the JavaScript, which is what the whole point is and why the resumability is important. Yeah, and that's the thing. I'm sorry for anyone who's newer on here. I've been writing articles about this for months and doing streams about this stuff for months. There's a lot of back context that people have been following along, but it was still worth me writing this new article about resumability because of this. So I think that we need to measure these things and understand the cost, right? Quick right today, like the status of it right now, it proves the potential that this architecture works. Like there's no gaps in the API design or like to cover the base case. There's probably more things we want to do with it, but it shows like this is a doable thing. But the implementation probably still needs consideration. They've been doing a lot of work now. They're kind of like on the second phase now where they're like, okay, we made it all work, but our server rendering is bloody slow. So they just replaced the DOM renderer with a string renderer, much faster, right? We saw that in the benchmark. But still figuring out edge cases on server rendering, client performance. These are all areas where they haven't given any consideration to. And now they're like, okay, now that we've shown it's a thing, can we make it fast? So we're gonna see over the next few months if they can make it fast. Right? There's different types of fast. Architecturally, quick has an advantage over almost everything, but in practice, we don't know that yet. We need to see the cost of serialization. Like I have to so is it better to have an app that is 4 kilobytes loaded eagerly with Astro, or one that's 25 kilobytes with Quick, but you didn't load it eagerly? Like there are devils in the details here, and I think that's what we're missing today. Anyway, so yeah, I mean that's where I started this week, and this helps you understand why I've been thinking about it. But yeah, this is a good read if you really want to get into the resumable discussion. And as I said, for myself, I jumped right to the 1.5 stream because there really wasn't much else for me. But what was happening, interestingly, is Solid's been getting a lot more attention the last few days, which I like. I've been seeing these great demos, partially probably because of Astro. We got this like Tory app thing. I love Nikhil's work on Solid and 3JS. But we're just starting to see this kind of like here's the suspense list and the 10 stack query example or whatever. We're starting to see like how Solid can actually integrate into other things, real workflows that people are having. Yeah, here's one. Migrated Zap run to Astro build with Solid. I gotta say, I'm really impressed. Right, another great Astro tweet. And why is this not liked? Okay. Astro's in app mode. They actually use client load, and it's actually just a Solid app on an Astro page. But because they have that kind of flexibility, they could just like, wait, the whole Zap app is Astro now. Well, technically, it actually sounds like it's Solid, but you can kind of see how these two pieces work together really nicely for a lot of situations. And this has been like I highlighted a few of these, but this has been the whole week for me, really. Oh, side note, if you saw this is pretty cool. It's like a little RPG type stuff where you pick your framework, and I was absolutely delighted to see Solid showed up on the list here of 8-bit icons. So yeah, really fun. Anyway, yeah, this has all been about 1.5 and thinking for the future for me, but there's more outside of the spectrum of Solid and all the great stuff that's been going on with us this week. So we probably should talk about that. And a lot of it seems to come down to this framework wars. I don't know what else to call it. The JavaScript runtime side of things is heating up big time. And as I said, last stream I was caught a little bit off guard when people were like, oh, did you check out the Dino announcement? And I was like, no, I haven't checked out the Dino announcement. And this week had its own share of controversy. Before I get into that, though, I just want to highlight this because this flew completely under the radar. I didn't retweet it or anything because I don't know enough about Next, but maybe people in the stream know about Next. But let me open this thing because what is this? 54 likes and 31 retweets for this thing. But if I understand correctly here, Netlify's created their own Next.js Edge runtime that offers a bunch of features that Vercel doesn't, especially things that I would consider like pretty standard, like being able to modify the HTML. I just don't understand what this is about because admittedly, when I picked up Vercel with SolidStart, like the day they released Edge functions, I literally just put SolidStart on Vercel Edge streaming and had it working, and I was like, bam, like drop the mic, kind of thing. It was just, it was easy. It worked great. I've been working on the build APIs, but it sounds like Next.js actually doesn't leverage the Edge functions very much at all. So Yeah, I'm very curious to understand this better because from what I'm reading here, this like if Vercel Next doesn't have this, I'd actually be compelled pretty. I'm just surprised no one's talking about this. Maybe there's too much other drama, but this seems like quite capable. It sounds like, just from the way it's saying, it sounds like a lot of the edge, like lower features, aren't available from inside Next, and I'm confused by that a little bit. So hopefully someone actually has more clarity there, but maybe worth people checking out. This feels very different from what I've seen from Netlify and Next in the past, where there's always this thing. It's like, oh, do you support this Vercel feature? Do you have ISR? Do you have this? But this is like, Netlify's like, no, forget that. We're actually just going to give you features that in Next that Vercel doesn't even have. I don't know. Surprised more people aren't talking about this. Oh, awesome news. The SolidStart is on 1.51 and the docs are up. So there you go, everyone. So yeah, this is interesting. Netlify Edge obviously works on Dino, so I mean, there's obviously some benefit from. I mean, what's interesting, Vercel's on Cloudflare, but from my understanding, the way Vercel uses Cloudflare is a little bit indirect. So there's still like some like. I've actually seen this slightly in benchmarks, that if you go straight to Cloudflare, it's a little bit more performant. I haven't seen the same difference when I compared Dino to Next or Netlify Edge, but I feel like I'm not qualified enough to make a full statement on that yet. I've only played with it cursive, was it like a little bit. Okay, so yeah, but this is only like one thing, right? I mean, we've been seeing like, where is it? Yeah, I mean, how can we not talk about what's been going on with Oven or Bun or whatever? Unsurprisingly to most people in my circle, at least, the Oven has raised $7 million to basically fuel a company built around Bun. So this is pretty big. Jared is going legitimate, so to speak. Although, to be fair, there was a whole drama around their hiring thing. And honestly, I'm not going to comment on it because it doesn't have to do with the technology. People can kind of feel what's comfortable for them. I've overworked at startups. I don't feel worse off for it, but it's a choice you have to make, and I wouldn't be surprised if, even though this is like a overwhelmingly negative thing for a lot of people, like in the sense of like the vast majority of people when they see this will go like, I wouldn't surprise that posting that he did gets him exactly what he's looking for. So I think the posting might have been a little bit aggressive. You never have the context in Twitter to explain what you mean, but this is not my area to comment on. I'm more interested on the evolution of how like the whole Bun and Dino thing is going, because if we go on Twitter here and we look up Dino, because I said last week Dino was like, yeah, we're gonna be the fastest, right? Straight up. And they released this 1.25 release, but some people are like, well, why isn't Bun in this benchmark, for example? And then there's some shots fired going here. Basically, yeah, correctness is important for database. We're comparing production software, not demos, right? So at some point, I think there's going to be I think that it looks like, unfortunately, we're going to see a little bit of fighting past each other. Like, I like when there's a focus on performance. Always kind of concerned when it goes to a place where and it's hard not to, where you almost need like third party to come in and kind of moderate this whole thing. Like, we may or may not have just shipped a new experimental HTTP server that's faster than all the other general purpose JS web servers, period. Okay. I think once you get into a game where you're kind of like posturing over who's the fastest, like as I said, just show me the numbers. I'm not. I can't comment on any of this until we see some numbers. So yeah, I think that there's gonna be some. I'm hoping there's some good competition here, and that drives people to make a better platform. I do see a bit of already aggressive jabs kind of going back and forth. So let's hope that curbs out. Is all I'm gonna say about this for now. It's tricky because you have companies that are funded and like that are mission driven, and they're trying to they're like, we have to be the best, and there's this like kind of tension there, right? And it makes me sad sometimes because then I see stuff like this, which is again kind of continuation of the love fest from last week where we had 11D and Astro. We got Quick and Astro here. I think they're at some conference in Zurich or something, and both of them have been posting how much fun they had with each other, comparing notes, talking about the different ways they can improve performance for page loads. I saw Nate did a whole thing where he was like, resumability blew my mind. I just love seeing this other side of it, which is very far removed from like it's interesting because both of these companies actually are companies as well. So it's not like this is completely removed from the VC side of things. It has a very different feel than some of the conflicts that we've seen in the past few weeks. Right? I think the thing on this side is on the Astro and the Quick Marco side, like we're at a point where we're building the benchmarks together because we're carving out new ground and we're showing what the performance can be. I don't know if it gets competitive at a certain point, but right now we don't even have the way of measuring it. So this is all just like, we know that we should have an advantage over the incumbents. So like we're doing work that can showcase it and better understand so we can improve, because that's what our goal is. I'm hoping that kind of improvement is the goal that comes out of this whole Dino bun thing. And it's not just like, who can post the fastest numbers this week? Yeah, you know what I mean? It's just, yeah, I'm looking forward to that. I did actually pick up this tweet, not to do with JavaScript, but just something for people to think about, because I will have to admit, the deletion of tweets on Twitter bugged me a lot, because as someone, because you don't have the source of thing to reference from, and since I was involved with a scuffle here recently, I actually feel like maybe it's worth a comment or two in here. There are a lot of situations where it's good to delete a tweet. Yeah. It's spreading information due to misunderstanding or situation change. It's being misinterpreted, your position changed, it's causing harm, you think better of it, you want to. Honestly, it's causing harm is the only thing on this list that I think is probably a legitimate thing. If your position changed, I guess, I wonder if it's a different problem when you're like at a different scale. Like if you have someone with 100,000 followers, you never get to correct what you've said on the internet. Someone will quote you on something that you don't even believe in anymore. Like something that you like literally could have changed your mind on it that same day you posted it, and it's there forever. So I do wonder if it's easy for someone who doesn't have that same kind of following to just go like, oh, I stand by what I say. So yeah, I think it's interesting to say at least. I do like that Kent is addressing it though, because this did get a lot of flack from people. and understandably. So, yeah, I don't know. I think this is an interesting thought experiment. And I think understanding the scope of your influence and being conscious of it is part of this. In a sense, Kent would know better than me or anyone because he has that kind of push or thing. Yeah, almost 200,000 followers. Right? Like, and some of these lines are pretty arbitrary. Like, it's causing harm could be in lots of ways, you know. So yeah, I think it's interesting. And then there's a question is if there should be a memorandum on deletion, like, or like if even if you would delete, should you leave it around for a week or something? Like, if I don't know, I think this is a interesting question. The best we can do is hope to post something that we would never delete. That's worked for me so far, but I don't know if maybe there's a future where that isn't the case. So anyways, it's just it's interesting, something to reflect on. I'm glad that they addressed it head on, at least, because this was kind of a criticism. Oh, I didn't talk. I got off Bun without talking about the last thing that I thought was really cool about Bun. We'll sneak it in here. While standard web APIs are great for compat, React is designed to be compiled for multiple host environments. We don't mind maintaining special builds for specific host environments to maximize performance. I thought this was really cool because Jared has come up with a way to make React's stream rendering faster on Bun, and he said it would work for Solid, which I'm pretty stoked about. And Seb is like, yeah, you know what? You come up with something for your platform, like, we'll build towards that. And I think it makes sense from, like, we see this in meta frameworks with like the adapters, but it's interesting about this kind of thinking in core. And I'm glad that this is the thinking. So, yeah. All right. Yeah. Let's see. Where was I? I guess, is there only one other big topic for this week in JavaScript? I want to talk about routing, because I love routing, and it came up again. Thanks, Theo, for this one. Svelte's been proposing a new router, and it's been kind of controversial. And yeah, I don't even think I have it up anymore. Let me see if I can grab the discussion. Like, just new, hot off the press this week, making huge strides here in terms of what the ideal way to structure stuff is. And a lot of people, when they see this, are just like, what is going on? But I think this is worth review by pretty much everyone who's kind of in this space, because I think that on the routing side, there's actually a few considerations in terms of these file system routing solutions. I mean, the first consideration is whether you should be file system routing at all. And to be fair, there's obviously that, like, first level where people are like, well, how should I put this? They're like, let's see, but a little bigger. Where you're like, yeah, I just don't like file system routing. But I mean, actually, at a more granular level as well. Like, should APIs be file system routing versus pages? Should actions be file system routing alongside with routers? Like, there's a whole question of what the split is. And, you know, even like, depending on the frameworks, if there's single file components, where the different pieces of the routing story get situated, because you immediately have this question of, like, I guess the second question, which is, how should you split the files, right? Like, should it all go in one file? Should it go in multiple files. And once you start kind of like going through the degrees of this decision matrix here, I think you start realizing what Rich says has maybe some more legs to it than you might have thought, right? Because this makes a huge difference. If your routing setup pushes you to have lots of files, then it can look really nasty. Like I think, where is it here? No, it's not. It's not a reply to this one. I thought that I saw an example where it's like the old version of Svelte routing versus the new version is like the new version is like 1,000 times better. They've gone to a really nasty place, and this is actually way better. But you look at these pluses and you're like, why are there pluses? Well, it's because he wants to indicate when you have multiple files that these are pages or things that need to be added as routes versus not. Like, because once you go multi-file, putting things as not, like, you hit an inflection point between like what is part of the route versus what is like not part of the route, right? Like should be bundled in. And this plus says like it's opt-in instead of the usual opt-out. So I think this is actually really interesting. I like these uses of shadow routes like this. Remix and SolidStart have this, but they use underscores. But I don't know. I like the aesthetic of it, so it's kind of interesting. I think the page versus layout thing, though, almost prices you more into the plus thing, because suddenly you now have more files right off the bat. So I think the next question here is, should your nested routing be explicit like that, pages, layouts, or should it be shadowed? And by that, it's the thing that Nux does and Remix and the SolidStart do. Whereas if you have a file the same name as the folder, then the folder is the children, right? And you can start seeing how these decisions start chaining into each other, right? So, like, it was funny. I took the really crazy Svelte version that this guy posted. I don't have an example of. Sorry, I don't have it at the moment. I'm not going to dig it out. And then and he had converted it to the new Svelte router, which was like half the size. And then I converted it to Solid, and it was even smaller, and the remix style. But the thing is, after I showed it to some people, they looked at it and they're like, wait, but I don't know what this does. Like, I forget what the rules are for shadowing. So, like, it's not as simple as just making it shorter and making it more compact, but there's a question of, like, explicitness, right? But there's trade-offs. If you have 1 billion plus pages and plus layouts, then, like, good luck finding which version of the files or whatever you're using. But, yeah, I think this is at a minimum, this is kind of an interesting topic to go through the decision points on, because it might start. Yeah, I'm missing the last point, right? What was the last one? After we do shadowed, it's opt in versus opt out. You kind of have to run through the whole tree and think about how this scales. And I wouldn't be surprised, because Next.js already decided to go explicit with the new routing instead of shadowed. I would not be surprised if they come to a lot of the same decisions that SvelteKit does, because, like, just simple consistency things, right? Because if you don't put the plus also, then it helps indicate what the page is, right? Like, or the layout is. Like, what if you had a route called layout? Right? I mean, there's complexity here, but, like, this is I think this is getting bad beats, and I think that when we look into this further in the future, people are going to be kind of surprised that maybe we didn't do things this way before. I'm not convinced completely, but I want to reevaluate everything along those decision points. So, but I'm not done talking about routing, because there was this really cool demo, again, Astro, where it's essentially doing these new page transition APIs. The interesting thing for me is transition APIs don't support MPAs yet, so they're definitely hacking something to make this look the way it does. But I'm still pretty stoked on the prospect here, because I think that this is kind of illustrating what MPAs could look like in the future without single page apps. So this might be a world where for, another place where like maybe you don't need a single page app, right? We saw a week or so back a Flamethrower from Fireship talking about doing some client-side kind of turbo-like routing. In our SolidStart stream, showed how to do nested server rendered client routing, hybrid, kind of like turbo links, but nested. I think we're going to see a lot of cool experimentation here, and I think examples like this are showing the way. I think the shared element transition API is probably going to be a big part of this, right? I talked previously about the generations of frameworks being defined by the routing solution, and in a sense, like we wouldn't have isomorphic apps today if we didn't have the history API and push state, because you wouldn't be able to refresh on a page, and have the / URL, because navigating to it would have caused the page to reload. Like to have client side handle the URL bar gave us this ability to have isomorphic frameworks, and that's something the browser gave us. I feel like shared element transition API is probably a big part of what enables the next generation of routing, which means it enables the next generation of frameworks. Yeah, but do you know what? My understanding is that the single page app mode was behind a flag, that MPA hadn't even happened. Actually, no, maybe he explains how he does it on the stream. Because that was my understanding, at least. Since the API doesn't support MPAs at the moment, I need to intercept the route change with navigation to add an event list or navigate to handle the DOM updates. Okay, so yeah. Yeah. Yeah, it might be interesting to see how that looks on a slow connection. One thing that I will point out, though, is if you presumably you're going to have to fetch for data on a slow connection anyway. So I wonder how different this would look like from, like, say, a concurrent suspense type situation where you basically hold the current page and then swoop into the next page as it finishes. It would be interesting to see. To be fair, to date, client-side HTML swaps have been felt slower than client render. So I don't know. I think that you're right. It's worth checking out. But yeah, this is interesting stuff regardless. And I just kind of wanted to talk about that and kind of showcase it. The last thing I want to talk about routing was going back to this question where we're like, should we file system route? And probably the biggest reason not to is the TypeScript side of it. And I know people have been looking into it. Tanner has made it very clear that he's very interested in React location, having full Zod TypeScript ability on the query parameters, like on every piece of it. And file system routing makes that challenging, to say the least. Sorry, just gonna... and I think there are actually only limited options that you can do there. I would love to see a way that we can get... Yeah, it's a hard balance, because the file system routing is becoming more and more prevalent and important as we continue to add like loaders and actions and more pieces that need to kind of integrate into the routing story. Wiring it up is honestly a lot, and it's just but on the other hand, there is this desire for this TypeScript ability, and as I had mentioned, like there are other solutions that people are looking at. Someone has this like code generator. Again, I don't know if this is my favorite approach, but it parses all your remix loaders and actions and automatically documents all typings per each route. Right? That's interesting. I think there's solutions I'm hoping with compilers to actually get us there, because while I'm not going to push anyone to file system routing, and I'm not saying file system routing is the best, it has that low effort launch point that is essential, I think, for the HTML first content build side. Like, I think if frameworks that are more like JavaScripty did JavaScript routes, no one would make as big of a deal out of it. But it kind of takes away a little bit from that, like, oh, I just have some HTML file fields for stuff that feels more static. And I don't like that we have to choose, right? And as usual, if TypeScript makes me have to choose, like I'm gonna brute force them side, because like that's what it comes down to, right? It's the same kind of question of like, should TypeScript dictate your APIs, or should TypeScript work for you? Anyway, all right. Anyway, I think that's mostly it. As I said, this week in JavaScript was maybe, I kind of wish there was more releases, but I and more new things to talk about. The stuff like the Netlify stuff and the Dino stuff, like the announcements were made, but I haven't seen as much chatter. But I'm still stoked to see all the new Astro projects coming to fruition this week, seeing awesome demos like this. So hopefully we can keep things positive into the next week and have another good week in JavaScript. So till next time. All right. How's everyone doing? It is hot where I am. It is definitely hot. Yeah, no, we've been going now for almost 4 hours. So, I think we've pretty much covered it, right? Talked about Solid 1.5, talked about this week in JavaScript and some of the stuff that's been going on. I don't think there's any sneaky benchmarks or hidden Dino announcements that I missed this time, but what do I know? And it seems like the stream's kind of chilled down, so I don't know. If there's nothing else, I think we call it. Ryan, any thoughts on SolidStart timing to do a beta release? I mean, I've been working on 1.5 because those features are key. I am now literally working on the last 2 features that I care about on SolidStart, which is we're doing a little more work on the action API. It's good, but I feel like we can do better. It's just clunkiness that's inherent to using forms everywhere, and I want to smooth that out a bit. I mean, it's not. It is the trade-off, and it has other places where it alleviates things, but I feel like there's still room. I want to review the routing. I think the Rich Harris stuff was important, but yeah, this is all kind of implementation stuff, and then I mean, it's just switch to docs and see if we can get the release out. We'll have hopefully a more stable, usable version even before the docs come out, and that's what I'm focusing on the next few days. So I think that I'm I'm hoping that we can get the beta release out in the towards the end of September. Maybe when I come back from Finland, I'll be speaking at React Finland September 15th. So got a lot of work ahead though. Like when I did, we're gonna have to find the right level of balance. It took me 6 weeks to do the solid docs originally, and I feel like we've raised the bar every time that people will expect more out of their docs. And that's probably what's going to push things back. But again, this is just a beta release. So as long as we have some stuff, and make that clear, I think it's okay that the docs remain a bit of a work in progress, but we need to cover the key parts. So that's what I'm looking at next. SolidStart is, now that 1.5 is out, SolidStart becomes more of the focus again. We got the pieces we need to get beta out the door. So that's what you have to look forward to. In terms of the stream, I'm hoping Dylan Piercy from Marco will join me, if not next week, possibly the week after, to talk about what it takes to make a language, like a TypeScript language server. Someone asked earlier, like, what if we could just, use Solid and build something like Svelte on top of it? I'm like, yeah, I mean, people have done that, but if you actually want to get the full benefit there, you have to do work. And Dylan's done this for Marco and Marco 6 coming out. And I think it'd be great to talk to him to understand what it takes to really make your own language in a JavaScript framework. So, yeah, I think that's what we have to look forward to. As I said, some great talks coming up. I'm really stoked for Finland. I'm stoked for VConf. So many conferences coming up. Jamstack Conf, JavaScript Days with JetBrains. Like I could go on. There's like something every week. JS Conf Poland. I think I'll see how that goes. So yeah, there's just a lot of really great things coming up. So front-end masters, actually. Plan is to do front-end masters first week in November. So yeah, a lot of really good content coming. Some more beginner-focused content, hopefully. Today's stream was all about all the advanced stuff. But, this is all part of the pieces that go into building performant, powerful UI framework. All right. Well, a lot of you stayed all the way to the end today, so that's awesome. Yeah, let me see here if anyone else is streaming on Twitch, although I'm not really good at this. I don't follow anyone or anything, so unless it's like someone I know, it's probably unlikely that no. I'm not a big Twitch person. So I think we're just going to wrap up tonight, this afternoon, depending where you are. Thanks for joining me, and see you all next week.